This conference will now be recorded.
Yes, good morning everyone, both online and offline. Very good morning. So whether it's audible online? Yes, please someone respond through audio so that I will make sure whether it's audible to me.
Yes, sir.
Yes,
Yes,
it is
sir.
audible. Thank you everyone.
Yes.
So today here we are for PD demo session, right? So what is my PD demo? My agenda of this PD demo session is what I'll discuss is first I'll start with, even there will be some seniors also who already know what is PD. So for that reason, what I'll do, I will start with session planning, right? How our sessions are planned. So how we are conducting the sessions. So first I'll start with session planning, and next I'll start with your queries. If you have any queries, then third I will discuss about what is physical design. Next is our course content. What is our course content? Next, fifth is again your doubt. If you have any doubts on the technical part, like on our course content, you can ask me. So this is my total agenda of discussion today for almost about 3 hours. So before going to what is physical design, why we have to do physical design, right? What is the steps in physical design, and what we cover in our course, entire course for 3 months. Before going to that, first I'll discuss about our session planning, how our session is planned, right? So our session is planned like two things. One is basic, another one is advanced. So we have planned a session in two things, right? One is basic, you start with basics. Next is one is what? Advanced course. So both integrated, right? Basic and advanced is totally for 6 months. So basics is around 2 months, and advanced course is about almost around 4 months. It is about the total. Our course is divided into two parts. One is basic course, one is what? Advanced course. And basic is for 2 months and advanced is for 4 months from tomorrow. So in basics, what is covered, right? So in basics, what we cover is digital, the digital basics. So what is digital basics here? What do you mean by sequential circuits? What is digital circuits and different types of digital circuits, different types of sequential circuits, and how to implement counters, other sequential circuits, right, by using basic gates, other things. All those things are discussed in digital. So as a digital is not very important to physical design, right? For front end is very important. Digital is not very important for physical design, but still in interviews they ask questions about digital. So if you see about the recent interviews where our student has undergone some product-based companies interviews like Intel and all, so they have asked most of the questions on basics rather than physical design. They've asked questions on physical design, but most of the first, see, the interview rounds will be not one round, 3 rounds will be there. So in the first round, most of the questions will be on basics. In third round, the questions will be based on your physical design. So basic questions will mainly focus on digital part, some concepts of analog like what is diode, what is applications of diode, right? So like that. So basics questions will be asked. What is your project? UG project, UG final year project. So explain about UG project. So test your communication, right? How good you are in communication to test that. So those questions are asked in the recent interviews. So for that reason, digital is very important. So apart from that, digital is important to identify the circuits in physical design. If I tell encoder, if I tell latch, if I tell flip flop, so you should be knowing what is the meaning of that, right? What is difference between latch and flip flop? Anyone can tell me what is difference? Okay. So any other answers? Yes, correct. Right. Flip flop is edge triggered, and latch is level triggered. So like that. So this basic meaning you should be knowing. Right. Apart from that, so digital is not very important. Only it's important for interview point of view. Right? You should be knowing all the circuits. So in interview, they may even ask implement 8 is to 1 mux by using what? 4 is to 1 mux by using 2 is to 1 mux. So this type of questions may be asked, which really will not use in physical design. But still they'll ask to test how strong are you in basics, and how much is your analytical skills. How can you analyze? How can you implement the challenges? Right? They may test you. So next is we discuss on GVim editor. See what editor I am using here, right? What is this editor called as text editor? This is a text editor what I am using. Windows text editor. Similarly in Linux, right, we have editor called as what? GVim. So how to use this GVim editor? It has many shortcuts. So in company, every time we use GVim editors. So you should be knowing how to use these editors. So how to save, right? Here to save we use what? Control? Yes. Control S is now, yes, Control S. So there how to save the file, how to edit the file, how to delete the line, how to copy from one file to another file. So all those commands are discussed in GVim editor. So different modes in GVim editor. So everything is discussed. So next we have Unix basics. See every EDA tool. See whatever we do in physical design, or from the front end, or from the synthesis, we work on EDA tool. EDA means electronic design automation tools. So we work on tools. So these tools are always installed in Unix environment. So we are going to install the tools in Unix environment. So when these tools are installed in Unix environment, so Unix is an operating system. As you have Windows, right? Similarly, you have Unix operating system. So how to interact with the Unix operating system? So there are specialized commands for that. So here creating the folder in Windows, what you will do? Right click, new folder, right? But there is a command for that. In Unix, there is a command to create folder. To copy file, how do you copy? Select the file, Control C, wherever you want to place, you use what? Control V. But there is a command there. How to copy files, how to copy the folders, how to search the file, how to search the word in a file. So you have many commands like that in Unix operating system. See, mainly physical design, you have to deal with plenty of reports. You have many reports dumped, you have to deal with plenty of reports. Searching the reports, copying the reports. Reports means what? File, right? Searching the file, copying the file. So all those commands, each and every command of Unix is discussed in Unix basics, like create directory, copy file, search command, grep command, awk command. So all commands are discussed in Unix basics. After that, you have CMOS basics. So this is important for physical design engineers. So even physical design as well as layout engineers should be knowing CMOS. What is MOSFET? What is NMOS? What is PMOS? What is CMOS? So what is the advantage of CMOS? How to implement different circuits using CMOS, like how to implement AND gate using CMOS, how to implement OR gate using CMOS, how to implement different gates using CMOS. So apart from that, layout, right? Layout is very important. I don't know how many of you know layout. What is layout? So layout of CMOS, how to draw the layout of CMOS? What are fabrication steps? So below 14 nm, 14 nanometer, when we reach to 14 nanometer, nowhere MOSFETs are used. We use FinFETs. So what is the reason for that? What happens when we hit lower technology? What do you mean by technology here? Distance between source and drain, right? If you see here, so if you see here MOSFET, right? MOSFET has what? MOSFET has P substrate, NMOS has P substrate. It has source, it has drain. So this is pure P substrate. So this is N plus, highly doped N type semiconductor is highly doped N type semiconductor. One is source, one is drain. And on top of this, you have silicon dioxide. On top of this, you have polysilicon. So distance between your source and drain, right? This distance between your source and drain is called as what? Technology. If I tell 14 nanometer technology, then what is the meaning? The meaning is the distance between your source and drain is 14 nanometer. So if source and drain comes very close to each other, see earlier there was 180 nm, we don't have any issues because source and drain were 180 nanometer far away. So when they are coming closer to each other, what is the problem we face? There is something called as drain induced barrier lowering. So how to overcome this problem? How to overcome this problem by using FinFETs. What are FinFETs? So all those things are discussed in what basics? CMOS basics. See, PD engineers even doesn't want this, but just you should be knowing all these things. Next, we need very important thing called as TCL, tool command language. TCL is tool command language. See our EDA tools, whatever EDA tools we use. So EDA tools, I'll talk about EDA tools in our advanced course. EDA tools is nothing but what tools we use for IC design. That is called as EDA tools. EDA stands for us electronic design automation tools. So for FPGA, right? If you want to do FPGA design, so we have Xilinx. But when we want to do ASIC design, the major vendors are Synopsys and Cadence. And few tools we also purchase from Mental Graphics. So even Mentor Graphics also has similar tools with Synopsys and Cadence has, but most probably we use what? Synopsys and Cadence in the companies. It depends upon the companies, which company you're working. Based on that company, they will use their particular tool. Some use a Synopsys, some use Cadence, right? So these EDA tools can understand only which language? TCL, tool command language. If you want to interact with the tool to make our work easy, then I can write a small automation program and I can fix many issues at a time. So doing the same work, for example, I have 1,000 violations. For 1,000 violations, I have to do same work. For example, I have a net. Net means it is a wire, right? I have a net, and this net is having violation. So find its driver. So its driver cell. What's a driver cell? Driver cell is a AND gate with X1 drive strength. You have X1 drive strength. Drive strength means how fast the cell is, how fast the cell is working, right? So you have net. This net is having driver. Driver means it's connected to what output. This cell is called as driver. Find its driver. Upsize its driver. If its drive strength is x1, then upsize to what? X2. If its drive strength is x2, upsize to x4. If drive strength is x4, upsize to x8. So whatever drive strength you have, upsize to next level. So if you have 1,000 violations, all 1,000 violations you cannot do one by one. For one net, you find the driver, find the drive strength, change the drive strength. Find second net, find the driver, find its drive strength, change upsize to next level. So do it continuously. That is not possible. Doing for 1,000 violation is very time consuming. You require 4 to 5 hours. So instead of that, write a small tickle program, small loop you write. The program only will find the driver of a net. It will check what is the drive strength. After checking the drive strength, it will upsize automatically upsize to the next level. So if you write a program for just 15 minutes, that is sufficient. Automatically it will fix what? 1,000 violations. So you have to learn. See, learning TCL is not only to learn about what is syntax, it's also to improve your programming skills. Right? You should be knowing how to write the tickle to get any information from the tool, or how to do the file operation, right? How to use regular expressions. So in tickle, the most important thing is list. So how to use list operations, how to do list operations, how to do array operations. So all those things you will learn in TCL. So apart from that, PD basics. PD basics is not required, but just we'll do for 1 day or 2 days PD basics, just to give idea about some terminologies. What do you mean by floor plan? What do you mean by placement? Just meaning of the words. What is routing? What is CTS? What do you mean by full chip design? What is subsystem? What is block level? Right? What do you mean by RDL layer? What is flip chip design? So just for terminologies, what is the meaning of that? Right? To discuss, we do some PD basics. Right? So this is about your basics course structure. This is done for 2 months, completed 2 months. So the basic course will run from Monday to Friday. Sorry, it's Monday to Saturday. Sunday is the holiday. It will run for entire week, Monday to Saturday. If you can attend on Monday to Friday, right? Some people can attend from Monday to Friday because they are working. If you can attend from Monday to Friday, then you can talk to institute. They will arrange the sessions only on Saturday and Sunday when you are available, because Saturday and Sunday is off for a few companies. So some working professionals, right? They can even opt for Saturday and Sunday. But other candidates who can attend on weekdays, they can attend from Monday to Saturday. So it is 3 hours per day. And this for 2 months to cover all these things. And advance, when I come to advanced course, so advanced course will happen in two things. One is lab or project. Another one is theory. See, theory, you will not do anything hands on. Only you will listen or you'll write down, you discuss your queries, right? So, theory is not like only PPT presentation, it's even we'll use a tool. The expert will use a tool or he will show how it works, but you will not do anything, but you will just follow the explanation in the theory, right? So, theory is done only on Saturday and Sunday for everyone. Saturday and Sunday it is done. It is for 3 hours per day, right? Saturday 3 hours, Sunday 3 hours. Means weekly 6 hours theory classes we have. And lab, right? Lab we have for lab or project. So lab or project happens from, so again lab or project we divide into two categories. One is weekdays, other one is weekend. So weekend is only for the professionals, working professionals who cannot attend on weekdays. Similar to this, right? So weekdays the session will be from Monday to Thursday. It will be from Monday to Thursday. Friday is the off, right? Because Saturday and Sunday you have what? Theory. Friday is a holiday for everyone. The candidates who are working weekdays, who are attending weekdays. So the session will be from Monday to Thursday. Lab, right? Completely lab. It's totally hands-on. So tool is given to you. This EDA tools. So tool is given 24/7. You can use the tool anytime you want. But lab happens from Monday to Thursday, 3 hours per day. So generally from 9:30 to 12:30. General timings it is. Some exceptional cases it will maybe from 2:30 to 5:30, but 99% it will be from 9:30 to morning, 9:30 to afternoon 12:30. So weekend, right? The candidates who can attend on weekdays, because some will be working, so they can attend on weekend. So weekend will be only on Saturday and Sunday after the theory classes, right? Theory both will attend. Weekday students will also attend theory. Weekends will also attend theory, Saturday and Sunday. So morning there will be theory for both weekdays and weekend. Weekday students will go to home, and weekend students will attend what? Lab after that. Because weekday students will attend lab on Monday, but weekend students will attend lab on Saturday and Sunday. So lab will be for weekend students. It will be from 2:30 to 5:30. So this is how the advanced course is divided, right? So we have theory on Saturday and Sundays for both weekday students and weekend students, and lab or project for weekdays it will be Monday to Thursday, and weekend it will be from Saturday to Sunday. And the queries may come that so whatever done on weekdays from Monday to Thursday, whether it can be sufficient to cover on Saturday and Sunday. Yes, it can be done, because the students enrolling for weekend, the strength will be very less, hardly 15, less than 15. But students enrolling for weekdays, the strength will be more. It is more than, it's 35 almost. So per batch we only go for 35 to 40, not more than that. Only 35 we use. So here we have 35 students. Here we have only less than 15. So obviously we can give more, we can cover more topics in weekend. So whatever covered from Monday to Thursday we can cover on Saturday and Sunday. So again, whatever sessions we do, even basics and advanced. See, weekend course, sorry, basic course, our plan is to have Monday to Saturday, this is a regular session. Saturday and Sunday, there is no regular plan, if at all, because what happens is the persons who are already working professionals, they know the basics. So they not enroll for basics. If you can, if you want basic course, and if you can attend on Monday to Saturday, sorry, Monday to Friday, if you can attend, then you can approach to the institute. They will arrange the classes for you on Saturday and Sunday according to your timings, right? Your mutually agreed timings. So when you and your mentor on what timings you both mutually agree, at that time they will do the classes, right? So this is not a regular planned sessions for us because it depends upon students who are coming and approaching us. Sometimes no one will approach for basic weekend. Sometimes they will depend upon, they will tell, okay, I'll see recorded videos. So we are not restricting you, right? You can approach the institute without any doubt. So they will arrange the sessions for you on Saturday and Sunday for basic courses. That is on mutually understood, mutually agreed timings. Right? Both mentor and the candidate at what time they will agree, they will conduct the session, and this is not a planned, pre-planned sessions, but it is pre-planned, right? Advanced course is pre-planned. We have sessions, compulsory session, theory on Saturday and Sunday, and weekdays we have Monday to Thursday for weekdays and Saturday and Sunday for weekend because many will register for weekend. We have at least 10 candidates every session who register for weekend. So next is tool. So first I will discuss about the project, right? Yes, mode of conduction, right? Mode of conduction. It is both online and offline. Both online and offline. So there is, see, always both are treated equally. Online candidates and offline candidates. Both are having equal opportunities for placements and everything. So you can attend either online or offline. You can switch anytime you want. It's your choice. But at the beginning, you should just tell the admin that you're attending offline or online so that we have to plan for a room. How much size room we want. See, last batch, if you see, I have a strength of 35, right? You should opt for big room. So when we have strength for just 20 candidates who are coming offline, we can have small rooms. So just you tell that I am coming offline, but in between you can switch whatever mode you want. So how the session goes on is like this, the same way how it is going on now. Now the candidates are attending offline as well as what? Online. So in similar way, sessions will go on. So that is what. So you can switch anytime. Online or offline, you can switch whatever mode you want. And So about the project, right? So this is the basic course which I've already discussed. The project. So we will do two projects. So these are the project specification what we use. So one project is done with help of mentor, other project is done, it's given to you to do after the course. If you're willing to do, you can do it. So first project means it's a complete flow of physical design. We will create take you through. So in the lab session, you will do one project, other project, right? Other project for the second project, whatever you have, that you have to do by your own. So we are doing two projects. So this is about the project specification, and so this is the block level design and area that I'll cover in the next classes. This is the content, right? This content I'll cover later. Second agenda, whatever agenda I have, I'll cover. So main thing we cover about this is a small programs, TCL programs, automation programs, right? So just we have these are the small TCL programs. So this so we'll make you people expertise how to write this program. So we'll take 10 to 15 examples to write the automation programs. So even we have e-learning course, right? Even we have both offline, that is mentored course, both offline and online. So projects, what we do is we do two projects. So project is two. So one will be done in the regular lab session, with help of a mentor. Right, mentor will guide you with each steps and each command. What is the command and what purpose we are using the command. Other project you have to do after the completion of course. So tool is provided 24/7, right? So when this advanced course starts, we'll give advanced tools, and during the yes, obviously our course starts from basics, right? So course starts from basics. So the course may start from tomorrow or day after tomorrow, right? It will start from basics. It will start from GVM or it will start from digital, because GVM is not big thing. Right? If students are not enrolled, still they're not at all enrolled properly, then we'll start with what GVM, because GVM can be done again once again for everyone. Right? Yes, this is what the basics which I have already told. Right? This basics we cover. So we start from basics. No, I hope you need to learn anything, right? If you have good knowledge of CMOS, digital, it is good. But anyhow, we will not be having knowledge of Unix and TCL, right? Anyhow, we are doing it. You need not to learn anything. You need not to have any prerequisite is not required, right? But only thing I suggest is if you are from any other background, like if you are from electrical background or if you are from any other background, so please attend the classes regularly without missing even a single session, and clarify your doubts immediately after the classes. If you have any doubts with the mentor, right? While teaching, if the concept is not clear to you, so please discuss with the mentor, clarify your doubts. See, all these are hands-on, right? GVM is a hands-on, it's not a presentation, it's not one-side presentation, it's a hands-on. So you will also work along with mentor. So you should bring your laptop. Yes, I'll come one by one to your doubts. So all these are hands-on. GVM is hands-on, Unix is hands-on, TCL is hands-on. Means these three topics you have to do by using laptop along with the mentor, because these are all commands. You should check how the command works. So assignments will be given, you have to do this. So digital is, it's like a presentation type, and even the assignments are given, you should do it. So CMOS is also presentation type. So PD basis is just 1 day or 2 days. In your advance is done. But these three things are hands-on, right? You have to do hands-on. If any topic is not clear, so please discuss with the mentor, either offline or online. Right? Both ways you can communicate with the mentor after the class. See, for every student, individual WhatsApp group is created. Official individual WhatsApp group. You will be there in that group. Along with you, a manager will be there, institute manager, owner will be there in that group, mentor will be there. So when you are in the basic stage, basic mentor will be there. When you go to advanced mentor will be there in that group. If you have any queries at any moment, you can discuss there. So when you register for every student, this individual WhatsApp group, see, you will be having official group where all students are present. That is used only to send the schedule. Every week we'll send the schedule. Right? Even though the timings remain same, Monday to Friday session is from 9:30 to 12:30. Even though it is same, but still we'll send the schedule every week, Saturday or Friday we'll send the schedule. So for that purpose, we have the group where all the candidates are present. Apart from that, you will be having individual WhatsApp group, official individual WhatsApp group. In that, you can ask any queries regarding anything, fees, tool issues, technical, anything you can discuss. Right? So our team will help you to clarify that. Yes, for e-learning, we will give the recorded videos. So e-learning happens in two methods. E-learning for basic course, we give recorded videos. E-learning for advanced course, when you come to advanced course, right, you are going to join the lab on weekend. But theory, you should watch recording videos. I'm talking about e-learning, not for the offline classes. Recording for theory, you should use for theory recording, you should use, and you should uh, learn. Even the recording videos are given for project also. If you have any queries, you can join for every weekend classes. That option is given for e-learning students. In spite of giving the recorded videos, even we will allow you to join the weekend classes. But theory will be recorded. See, sessions can be attended even offline or online. Right? It's mode of joining is your wish. If you are even in your native, you can attend the classes. Right? So there is no we are not going, there is no restriction in that. So holidays, I think on the day of Sankranti there may be a holiday, but it's like other states, they give holiday for 1 week, right? Such type of holiday is not there in this state. So there is no holiday, like 1 week holiday is not there. But on the day of festival, the holiday will be there. On the day of festival, like it is on Sankranti or it's on some other day, the holiday will be there. But apart from that, 1 week or 2 week holiday we don't have. Okay, when I talk about my classes from 9 to 12, I am from IIT MTech, so I can access recorded videos or not. Okay, sure. So I'll discuss about that for online. Okay. Recorded sessions will be available soon after the class. Yes, see, attendance will be monitored. First, I'll tell that attendance will be monitored. Right. So, attendance will be monitored for two purposes. One is to know your interest, right? See, you are not attending any classes, and later you claim that you didn't get the placement. Then we cannot take the responsibility of that. Correct? If you are not attending, if you have paid the fees, see, I'm not telling about all the students. Few students who are not responsible, right? So they pay the fees, they'll join to PG, they will never come to the institute. And at last they claim that I have paid the fees and I'm not getting the job. See, paying the fees will not give you the job, right? So focusing on the course will give you the job. So for that purpose, we will monitor the attendance. So for any cost, if you cannot attend the classes, that is okay. But you should be serious about your course, right? So we'll conduct a regular mock interviews. We conduct regular We'll conduct regular mock interviews. We conduct regular test. Right? If you perform better, right, that is sufficient for us. It's not that you should attend regularly for us, right? You should perform good in our mock interviews. That is the thing. Uh, yes. Yeah, what I'm telling is that is what I'm telling, right? We monitor the attendance for two conditions. One is whether the student is having the interest or not, right? To get that feedback. So we see monitoring attendance means simply seeing the attendance and being will not simply mark you as absent and will not be silent, right? We will call you, we will ask you why you're not attending. If you tell genuine reasons, right, it's okay for us. And we'll motivate you, just attend the sessions. So one is that thing. Second thing is we will also ask the feedback from the students. Why you're not attending? Is there any problem you're facing in our institute? Is there any problem from the explanation? What is the explanation done? Whether you have any problems, right? All these things are asked. So for that purpose, we also monitor attendance. So if you're not attending regularly, it's okay, but you should perform good in the test and mock interviews. And we do two projects, and tools are given 24/7 to home. So during the advanced course, when the advanced course is running, you will get the tool for this complete 4 months, and you will also get the tool after 15 days extra after course completion. For example, if I tell that my lab is completed today, next 15 days you can access the tool for the practice purpose or doing some other another project. If you want still extension of the tool for another 15 days, you can talk to the mentor or sorry you can talk to the mentor or you can talk to the admin and you can get extended. Means you can get extended even 1 month after the completion of course, till 1 month on request, right? But after that we will remove the tool access. So tool access will be there 1 month after the course completion. So tool will be given when the advanced course starts on the first day. First day starts with the tool installation only. So tool access will be there till this 4 months plus 15 days. That is a regular schedule for us. On request, we can also extend this for next 15 days. Right. So I'll come to the placements also. So fee structure, please talk to the institute. Right. Please talk to the institute what is the fee structure. They will clearly mention you what is the fee structure. So as I'm a technical person, I'm not aware about the fee structure. Talk to the manager, right? He will explain about the fee structure. I think it's available in that our this one also, that promotion whatever we are given it. The phone number is there. Please call to the manager. He'll guide you. And record videos. Right? When I come to recorded videos are given. See, two recorded videos are given. One is pre-recorded video. So pre-recorded video from our best mentor or best trainer. whom we assume that is pre-recorded videos. Those videos which we give for e-learning. E-learning means only they will attend, they will complete the course by seeing recorded videos. So those recorded videos we'll give. One more thing, what we give is we give live recorded videos. Live recorded videos means whatever the recorded videos of the current session going on. See, if I complete the class today, immediately after the 4 hours, because we require 4 hours to upload the video in the portal. Immediately after 4 hours, you will get the video. So you will also get live recorded video. So this is given. This live recorded video, right? This video, live recorded video, is given only if you miss the classes, right? You can watch the live recorded videos. But live recorded video is given only after 3 hours of completion of class. For example, if I complete the class at 12:30 today, so you will get the live recorded video at 2 o'clock or 3 o'clock. It will be uploaded in your portal, right? So this live recorded video will be available for next 15 days. After that, it will be refreshed. So it will be available for next 15 days. So today session will be available for next 15 days. Tomorrow session will be available for next 15 days. From tomorrow to next 15 days it will be available. So day after tomorrow record video will be available for next 15 days from day after tomorrow. So like that, these record videos will be available in the portal. So they will give you the portal username and password, and that recorded video will be available to you for both for theory as well as lab, even as well as for basics. For all the courses we have recorded videos given. So one recorded video will be pre-recorded, that will be present, that will be given to you for entire course duration. We will not remove this. Another video will give us a live recorded video. So this live recorded video will be there for next 15 days from the day of completion of session. So this is about your recorded videos. So when I come to the placement, so obviously notes will be given, right? Whatever we do today, that notes also shared, right? PPT is also shared in the portal. Even separate hard copy of notes is given. See, physical design, theory content is of no use. Means whatever notes, PDF, everything, it's available in the online portal, online, wherever you search, online, everywhere it's available. So physical design, most important thing is tool. Lab part is very, very important for physical design. This is very, very important because tool is very costly. Two licenses almost 30 to 40 lakhs per year. It is for 40 license tool is very costly. EDA tools are very, very costly. Most of the service based companies will not be having tools at all. So only product based companies will be having tools, right? So lab portion is very, very important for physical design engineers. So lab, whatever they are doing in lab, right, everything is recorded in a file like this, whatever they do, and that file is given to you for access. You can use it, open the file, and you can see. If you miss any command, you can open the mentor will give you the path. In this path you can find the file where everything is present, all the commands are present. You can open that and you can see that. So every session what they do, every notes is shared again to you, and even pre-recorded PPTs or pre-maintained PPTs and pre-maintained PDFs, everything is given to you. They will give you whenever this portal is given. Along with this portal, all these things will come automatically. See, pre-recorded videos is available for entire course duration. So there are two videos, right? Pre-recorded videos. Pre-recorded videos means this course is done long before, some 1 year before, or 2 years before, from some best mentors or best trainers. So that video is available for with us, right? That is available. This pre-record videos we are going to give for entire course duration, and the live record video is given to the candidates, right? And it's available for next 15 days from the day of session done, and it will be refreshed after 15 days. So when I come to placements, right? So now physical design placement is very good, and even you can see the notice board, right? Even we have the candidates placed in product based companies. So MediaTek, Nvidia, Intel, right? We have candidates they are placed in this product based companies. See, when I talk about the placements and percentage of candidates getting placed, right? See, the only thing we want from the candidate point of view is you should be prepared enough to handle the interviews. So if you are prepared enough, see, when we conduct the mock interviews, when I conduct the mock interviews, we ask the questions which is very basics. We not ask any complicated questions. Mock interviews make, see, we conduct mock interviews just to filter the, it's not to filter the candidates. It is to make sure that you are prepared before attending the company's interview. See, if we send the non-prepared candidate who is not well prepared, and if we send him for the place for a company interview, and the company feels that this VLSI guru is not producing the good candidates, and they'll not come back to us again. So for that reason, what we do, we will scrutinize the students, and we'll give the feedback also, right? Based on the communication. So based on the, see, the questions for freshers to test your communication also. So how good you are in communication. So using the keywords, right? So in company, elaborating the thing is not important. So how short you talk, and how easily you convince your team lead, how easily you put your idea in front of team lead, that is important. So you should use some keywords. What should be, means technical keywords, right? So flip chip design, RDL bump routing, right? So if I ask the fresher, if I ask, sir, I am routing from IOPAD to the RDL bumps, so I have some issues. So instead of discussing all those things, just mention, sir, while doing RDL bump routing, I have this issue. That's it, right? So there's a keyword, how to use keyword, how to make your explanation short and complete, interesting, right? How to make it. So all those feedbacks will give in the mock interviews, right? So for example, if the question is asked like this, so how setup and how skew is going to affect setup and hold? Skew, right? Positive skew and negative skew. Just one word answer. Positive skew is good for setup. Negative skew is good. Negative skew is good for hold. That is sufficient. So, simple answer it is. So thereby the interview understands that you know the concept. So elaborating in any other way, writing the equations is not required. Sometimes it's required when the interviewer asks write the equation, and it's required. So giving all this feedback, everything we will do in the mock interviews. So if the student clearing the mock interviews, right, so obviously every student is placed. So more than 5 to 6 opportunities we have given. Within this 5 to 6 opportunities, right, they'll get the job. So when I come to placements, there are service based companies, and what, there are product based companies. So service based companies and product based companies, we talk about this, right? So service based companies will hire the candidates. They will do some small training. They will teach you what to answer in the product based companies interview. So when you are hired in service based companies, you will work in the projects of what? Product based companies. These service based companies will not be having any projects. Their role is to hire you, and they will ask you to work with what? Product based companies projects. Or product based companies will give complete project to what? Service based companies. That is called as ODC. Right? Off the shelf. Complete project of product based companies you give to what? Service based companies. So service based companies will hire the candidates, and they will make you to work with the projects of product based companies. So for especially for physical design, right? Product-based companies will not hire the candidates with less than 3 years experience. So they have their own things. As a fresher or less than 3 years experience, they will not directly hire you. So even though they hire you, they will hire you like a contract basis, or they will hire you as an internship for this product based companies. Or if you are having experience more than 3 years, they will hire you. Every company has their own policy. If you take about, just I'm giving an example, take about Qualcomm, right? So Qualcomm at least requires 3 years experience. 3 years experience in that too, you have to work with Qualcomm itself. 3 years. It's not 3 years wherever you have. So you are some service based company employee, and you are working with a project of what? Qualcomm itself. You are working with the projects of Qualcomm for 3 years. You have worked. Then only you are eligible for getting into. Then only you are eligible for becoming a permanent employee for Qualcomm. That is the eligibility criteria. So I'm not talking about. I'm not telling that you don't have opportunities of product based companies. Obviously you have. So you have, either if you are experienced, you have, obviously they'll take you. Even you have worked in some other domains of not even directly on physical design, some other domain like Redoc or some other domain, and if you do course here, and if you apply, they may hire you in product based companies, right? But most of the opportunities will be having, when you have most of the opportunities in what? Service based companies. So they will hire you, they will do some small here and there, they'll do some small training, and they'll send you to the projects of product based companies. So whenever product based companies come up with the intention that we are going to hire freshers, obviously VLSI Guru have sent most of their candidates to product based companies. Recently, I can tell Intel has come. Intel has they were ready to hire the freshers also. They have come forward, right? And most of, I think 3 to 4 candidates are placed in Intel. So the condition is, it's not a full-term employment; it's a contract basis, and their condition is, if you are good in this 2 years, then we'll make you the permanent employee. That is what their condition with Intel condition, right? So the candidates who clear the mock interview or final mock interview, obviously 200% they'll get the job. I'm not even telling 100%. I'm telling what? 200%. So to clear our mock interview, you need not to be very good expert, right? Only we want is good communication. It's not expert English, little bit good in English, right? And second thing, requirement is you should be knowing basics properly. So we ask questions like explain ASIC design flow, explain setup violation, explain hold violation, explain MCMM file, which we have already explained. So we are going to ask which we have already explained to you. So prepare for that and attend the interviews, right? And when you go to interview, there are two types of questions. One will be like 60% to 70% questions will be on basics, right? Whatever basics you have learned. So you have questions almost 60 to 70%. Just 1 minute, I think it's stuck. So and remaining 40% of questions will be, it is uncertain. They may ask any question. They may ask questions from their experience. They may ask questions to think, right? Sometimes they may ask questions to evaluate, right? They'll give one scenario, right? This is the problem, what is happening. So what is the slack value? So to fix this path, what you can do? Right? They may give some scenario to think. So all those things they may do. That is 40%. So even though that 40% is uncertain, but at least the 60% you have to answer comfortably without any problem. Then you obviously will clear the interview. But 40% is always uncertain, right? You may answer, you may not answer. You may come up with a different type of handling it, right? So that is okay. But at least 60% of question which is from basics, compulsory you have to answer it. Yes, see, obviously we cover everything, right? So I told it's uncertain. Uncertain means we don't know what they will ask, but 60% of questions are compulsory. They will ask. So explain ASIC design flow. Explain about your project. Explain different fixing methods at each stages. Explain analysis done at each stages. So these are 60% questions which are fixed. So this obviously compulsory they will ask. Explain different power reduction techniques. So we have set of 40 to 50 questions. So those questions will fall under the category of what? 60 to 70%. Compulsory they will ask. But 30% is uncertain. They may ask any questions. Obviously, we cover everything, but sometimes it is uncertain. They may ask any questions, which is one or two questions, which may be even we are not sure why they have asked that. Right? So apart from that, see, it is not that you should compulsory answer those questions, but compulsory should answer basic questions. So then obviously will clear. The interview will never expect you answer all the questions. They expect you should answer at least the basic questions right. Other things depends. Other things will help them to filter out, right, who is best out of, if they require 5 candidates and they have 10 candidates as best, and out of 10 whom I have to select, in that case other 30% will come into picture, right? So because I have many times done the interviews. So next is you can ask your queries for 5 minutes, because I have handled most of the queries. If you have any other queries, you can quickly ask for 5 minutes, then we'll go with a technical discussion.
Hello, sir.
And I will make one thing clear: the course is for 6 months. 2 months is for basics.
Hello, sir.
Advanced course is for 4 months. Yes, please tell me.
Yeah, actually, sir, if anyone want in weekend classes, so how many days to take complete the course? If he is available in the weekend only,
Same duration.
same days.
Yes,
After
same.
6 months, they have complete.
Yes, sir. Same duration is required to complete even for weekend. See, same duration means 1 week or 2 weeks. Hardly it may go extra. Hardly 1 week, but almost the same duration.
So at in the weekend classes, that not they have not a more burden if he come at any weekend
No, yes,
because
that is what I told, right? See, okay, I already clarified this. I'll tell once again. See, Monday to Thursday, the candidates who are attending for us, the strength will be minimum 35, maximum also
okay.
35, because we will not take any candidates more than 35. See, now current situation. See, even we had a batch less than 35, but current situation of enrollment from past 2 years, we have a batch of 35, not less than 35. So weekdays, the candidates will be with the strength of 35. So handling all 35 students. See, 35 means there many are freshers. So they will do some
Yeah.
mistakes while typing the commands, everything, right? So giving importance to each candidate, clarifying their doubts, going forward, right? It takes a lot of time in weekdays. But weekend, the strength will range from 5 to 15, right? Even sometimes it may be 5, less than 5 also possible. So on average, it will be from 5 to 15. So if you have 5 candidates or 6 candidates, it's very easily we can handle, right? It's not very difficult to handle it. So you can compare. This is 3 times more than this strength. So we can cover the same topics which is covered on Monday to Thursday, on Saturday and Sunday, because the enrollment will be less here. So reaching to 15 is rare condition. So generally we have like 5 to 5, 6, 7. That's it. And even that 5 to 6, 7, some of them will not attend. because of work pressure or something, right? They will not attend. Even on those days, they will depend on recorded videos. So the students who are attending weekend is less strength, so we can cover the same topic which is done on Monday to Thursday. That is how we can cover on same duration.
So in
If,
weekend times,
for example, I'll give one
you are
example, right?
providing, yeah, hello.
For example, I'll tell you, if I
Uh,
start tool installation if I do for weekend and weekdays. So weekend tool installation will happen in half an hour. But for weekdays, right, it will take 1.5 day. First day, 3 hours is done. 1.5 day means it's not. I'm not telling about 36 hours. I'm telling about first day of 3 hours. Next day, again we require 1 hour to do the complete tool installation because every student will come up with their own problems. I have some
yeah, yeah,
issue. My tool
sure.
is not installing, right? So that is what the difference is. But for weekend, hardly we have 6 to 7 candidates. It will happen within half an hour. In out of seven, four will follow. If three are not following properly, then mentor will take the control of the laptop. He can easily do it. But that is not the case in weekdays, right? That is what the difference is. That is what the time difference happens from weekdays to weekend. Yes, come
So,
ask me any other question.
so within the first 2 months, you are not providing the tool.
No, see, this tool is different, right? First 2 months we are working with basics, right? So we are giving the. See, it is not a tool. I can't tell it a tool, but we will help you to install all these things. It's a freely available. All these things, GVM editor, Unix basics, Unix editor, right? Means there is Sigwin tool is available. We are not asking you to install the operating system Unix. So there's a Sigwin tool can mimic the operating system of Unix. Whatever Unix commands we are using, we can use on Windows itself by using Sigwin tool. So these three tools we use during the basics. So
But sir,
this itself will take.
we can do the TCL program in ICC2 tool. So that time you allow to provide tool.
See, here this is tickle basics, right? Here we teach how to understand the tickle basic. This is, see, when we come to advanced tickle, right? So as I shown in this PPT, advanced tickle. In advanced course, we cover advanced tickle, right? In advanced tickle has IC2 commands plus basic TCL command. So basic TCL command here we have taught. So when you come to advanced, obviously in the lab session we will teach you how to use this basic tickle along with IC2 command. So when you come to advanced, then only we'll use the IC2.
So one more question, sir. Actually, sir, if
We are not
that
using
new
IC2 from the previous batch, from the next batch. So here we start using Fusion compiler. So tool used here is Fusion compiler. Yes, tell me.
yeah, actually, sir, you are providing that e-learning courses. So e-learning courses you can access anytime. That person who joined the weekend, yeah, weekdays, both are available e-learning courses.
The e-learning is not a mentored session, right? It's a recorded videos will be given to you. How e-learning works, I'll tell you, right? It is a
Yeah,
for other
b-
right, for other courses. Our structured plan is right.
both can access both can access weekend and week candidates both can access this e-learning.
This is not e-learning. This is the videos given to you, right? This is e-learning videos only. Anyone can access these videos.
Okay, okay. There
See,
have
e-learning
provide.
cost is different. This cost is different. E-learning has less cost compared to this.
Okay. Actually,
If you
sir,
opt for e-learning,
there you have provide complete courses in the e-learning.
yes, e-learning is for complete course. Complete e-learning you have basics. Even you have advanced also, but only record videos will be given. So mentor help is given only once in a week. If you have any queries, once in a week you can talk to the mentor for 1 hour or 2 hour, and you can clarify your doubts. That is about
Okay.
e-learning. If you opt for it, this is what I am discussing is not for e-learning. This is for live sessions.
Yeah, yeah.
So mentor help is given once in a week. So when you come to advanced e-learning, right, as a mentor help is given once per week. Instead of that, we are allowing you to attend what weekend lab itself, because that is also happening on twice in a week, right? So institute has gone one step extra. They are asking you to attend the weekend lab directly instead of having queries and discussing with the mentor. Directly, you can attend the weekend lab, so you can follow the weekend lab directly. But theory, you should go with recorded videos only, pre-recorded videos for e-learning. But whatever I am discussing now, this is a not e-learning; it's a live session.
Okay, okay. Okay,
So
thank you.
e-learning is available for all the courses. Even we have synthesis and STA separately, right? So we have all the courses, even front end, DFT, e-learning is available for all the courses. Yes, certificate will be given. Certificate will be given from VLSI Guru that you have done the course. So when I come to placement, I complete the placement thing. See, placement happens like when you clear the mock interview. So we are going to put it in you. Your name will be again. We will add in a group called as placement group when you clear the mock interview. Right? So all the placement opportunities will put in the placement group. Any placement opportunities there, we'll put in that. So we'll send on Excel sheet. If you are interested, then fill this Excel sheet. So you have to upload your resume also there. So VLSI Guru will collect your resume and they'll forward to the interviewer, and directly you will get the call from interviewer, or they will inform us and we will inform you to be ready for the interview. So we only collect your resumes and we will only forward you to the interviewers. Whenever this interviewer they have their vacancies, they will approach us. So when they approach us, obviously we collect the resumes and we'll post in the group called as placement group. So in placement group, there will be candidates only who have cleared the mock interviews. So not clear the mock interviews, we give enough time. You can clear any time. It's not that you should clear immediately after the course. If you have any health issues, anything, right, you can clear anything, anytime you can clear the mock interview. If you are prepared, right, if you're prepared for the mock interview, in your individual WhatsApp group, you can tell that I am prepared for mock interview. So we'll assign one mentor or we assign an expert to take the mock interview. And if you're cleared, we'll move to the placement group. If you're not cleared, again you can retake anytime you want, and you can take n number of times. And it is recorded, right? The interview is recorded, so everyone can see how the interview has done. If there is no mock interview, there is no uh, confusion in that, right? So even candidate cannot blame the interviewer, and interviewer simply cannot blame the candidate, right? So everything is recorded, and we can anyone can see how the interview is done. So in mock interview, we are not going to ask any different weird questions to filter you. So it is the basic questions, and whatever we have done only we ask you, and we test your confidence level, we test your communication skills, how good you are in explaining the things. So if you are not good in communication, please talk to the institute. If you need some special uh, skill development classes, right? So I think they may provide you. Right? Talk to the institute. You talk to the manager. I think they may provide you. Yes, e-learning students are also eligible for placement without doubt. See, we need a candidates who are very good, right? Who are very good, who are having good knowledge. We need a candidate. Let them be from e-learning or let them be from the live sessions. See, what is the difference between e-learning and live session is the placement approach, everything remains same. But live session is you have a opportunity to discuss with the mentor every day. After the class, you can ask. During the class, you can ask. Right? You can do. You have always see if you are not following anything, you can stop the class in between. You can ask, clarify your doubts, and you can go after. You can proceed. Next step, you can go. That is what an advantage you have. So from e-learning to recorded videos. See, basic salary is like, see, service-based companies will send you to the projects of product-based companies, right? So product-based companies will conduct one client interview. They'll not take as your fresher, right? Because first time you're entering to the project of, even though I have worked 15 years in Qualcomm project, but when I go to when I go to Qualcomm again, I don't want interview because I was already I've already worked in a projects. But when I go to the AMD project, obviously AMD will take interview with me, even though I have 15 years of experience in Qualcomm. But I'm going to the first time I'm going to the AMD will take first interview with me, obviously. That is called as what? Client interview. In client interview they will ask what projects you have worked previously. That they will teach you. Service based companies will teach you what you have to answer in that. They may ask some questions to test your caliber, right? What is the command to do this, or how do you fix these issues, right? They will do. So that is what this product based companies will do. That is called as client interview, right? So when you go to service based company, right? So when you, till the time you clear the client interview, right, your salary will be 15,000 per month. They'll not pay you anything. They'll only pay you 15,000 per month. As soon as, because they'll not get any benefit of you. Once you clear the client interview, because even they are not sure you'll clear or not, right? As soon as you clear the product based company's client interview, that depends upon your caliber, how much time you take. See, some candidates will clear even in 15 days, some candidates will clear in 1 month, some candidates will clear in 6 months, some candidates will clear in 1 year. It depends upon your caliber. But according to my knowledge, the candidates will clear within 1 month to 3 months. That much time is sufficient. And even it also depends upon how much interview, client interviews your service based company is giving to you. It's not that every person will clear in one interview, right? Even you require 1 or 2 interviews. So how much interviews they are giving you? See, if you join to service based company and the service based company is not at all giving you the interview, client interview, then it may even take more time, right? But even it is loss for them, even it's loss for you. So even they will not do like that. It only depends upon the situation and what is their company, how it is, company policy is going on, and what the which company they have tie up, right? How their relationship is with private based companies, everything depends on that, right? So average time, according to my knowledge, average time is 1 month to 3 months. Within 3 months, obviously will clear. So after clearing the client interview, product based company client interview, it depends upon what is your experience they have claimed, right? In product based company, that I cannot tell officially, but still I'm telling. In product based company, they have send you to product based company with 5 years experience, 4 years experience. So they'll put 3, 4, 5 years experience, right? So what experience they have claimed on you, based on that your salary will be depending, right? If they are claiming only 2 years experience, 1 year experience, it will be like 50,000 or 60,000 per month. So if they are claiming 4 years experience, 5 years experience, it will be like almost one lakh per month. So it depends upon how much experience they are claiming on you. It depends upon that. See, if you have year gap, they may claim more experience. If you're very good and if you have year gap, they will claim more experience on you, right? And if you don't have year gap, so year gap is good in physical design or here, right? Because the service-based companies will claim experience on that. And if you don't have any year gap or you're passed out recently, and then obviously they cannot claim experience on you because your pass out tells 2024, and they cannot claim that you have 2 years experience, right? So then obviously when they claim 1 year experience when you're working on ODC project, so the salary may range from 40,000 to 50,000. Depends upon what is your experience they are claiming, right? On that they will fix the salary. So recently our candidates have claimed with 3 years, 4 years experience, so they are receiving almost 1 lakh per month. So how much they are claiming on their experience, right? That depends on that. See, claiming the experience is not required. Showing that much expertise is required, right? After you posting into a product-based company project, obviously for every person the flow is different. See, even though I have 15 years of experience in working in Qualcomm, as soon as when I go to AMD, right, the tool is different. Qualcomm, I would have worked with Innovus, but in AMD, I may work with Fusion Compiler. The tool is different. Obviously, flow is different for me. So when there is a change in project, everyone is going to have some that. What I can tell is some time is required at the beginning to learn the things. What is a flow? How the flow is working? Everything. So learning flow happens with everyone. It's not only with the freshers. Everyone has to learn the flow. But after learning the flow, the concept remains same. After that, how good you are in handling the issues. So this issue is because of what reason? How good you are in understanding that. So it depends everything on that. So your team lead tells you today, whatever cells you have here, pull near to the port. Port is having connection to this cells, identify and pull near to the port. So first of all, to do this, you should understand what he is telling. If you're not understanding what he is telling, you don't do anything. Even though you are understanding what he is telling, whatever cells you want to pull, it is of huge count, like 10,000 cells, then you cannot pull one by one. Then you should be having idea what method I can approach to do this. I have to write some automation TCL program. If you want to write automation TCL program, right? Then how to find from the port to the cells connection? I have to find how to find the connections. What command I have to use to do that? So after knowing all these things, then if you write a TCL program for just half an hour, and if you execute, right, all these cells will be pulled near to the port. So this totally depends upon your coding skills, how you can do it, how you can do the TCL, right? So every company, every time the expectation will be different. It's not the same thing will be your lead will be asking, right? Every time they'll ask different scenarios they'll ask you to do. So you should be very good in tickle programming to do all these things. So then you can grow very fast. So I have taken your questions. I think most of the questions I have taken. So if you have any questions, right, you can please ask me at the last again.
So every students provide a separate mentor.
So that is what see every student separate mentoring. See the classes will happen with a single mentor, right? Monday to Thursday, 35 students with a single mentor. Saturday and Sunday, right? Single mentor. Right? As I told you, there is an individual official WhatsApp group, right? For every candidate, there is a separate WhatsApp group. In that, manager will be there, owner will be there, admin will be there, right? Any queries if you have, you can post in that group. Not only technical, anything you can have, tool point of view, technical point of view, or anything, right? So if you have any problem, or see, one option is you can discuss during the session time. So during the session time you cannot get something, right, you have missed something, then you can post in that individual official WhatsApp group, and obviously a mentor will be assigned to you to clarify the doubts.
Sir, one more question, sir. It is not uh, you you cannot provide for starting in the starting to allow the access of tool.
Can you come again? I didn't understand what you asked me.
Actually, sir, I'm saying that it is not possible to allow the tool as the starting of the point.
See, you are asking whether we cannot give the tool from the day of one, right? During basics only.
Yeah, yeah, yeah,
What
yeah,
you will
yeah.
do with that? You tell me first. If you give the tool, what you will do with it? You know how
Just
to
for
use the tool?
learning purpose, sir.
You know how to use the tool?
No,
Then what you will do that with that?
no, sir. But only for learning purpose, like slowly, because slowly we just start for the starting part.
No, if you doesn't know how to use a tool, then how can you learn that? We are going to teach you only when we come to advanced course, right? Then what you will do with the tool in the beginning?
Actually, sir, that candidate who joined the weekend classes, they're definitely working some service-based company. There are some need. That's why for in training, and he need for tool.
No, no, see, that is
That's why I'm
company's
saying.
responsibility, right? We cannot take that responsibility. I don't understand what you're asking, right? That is totally violation of. So he cannot ask us like this. How can he ask like this?
So actually, I only for trying for the first because it for
So
tool I
you're
think
telling
it
that
take
service-based company is asking the tool. That is what you're asking.
yeah. Many actually many companies are asking for which tool you are learning. That's why I'm asking, sir.
No, you're already placed in a company. No, any
No. I
specific
just
thing you
trying.
have, right? Any specific thing you have, right? You can come and discuss in the institute, or you can talk to the manager, right? If you have any specific thing to be done, so if you tell that you give me the tool, it is helpful for me to get the company. And if you tell, okay, you give me the tool from the day one, I know how to use the tool, then you can talk to the manager and you can explain what is your thing and you can get it done, right?
Okay.
According to our course content, we will give the tool only after the advanced course started, because two licenses count for everyone, right? If we have two license for 100 people, then the person who is 101 person who is logging in for the tool will not get the license. So how much
Okay.
license we have? Only those much license we get, right? So we have planned according to the course requirement. Which course? See, whatever course is running, those students should get the tool for sure, right? So we have current running batches, previous batches, right? They should get the tool. They should get the license. So any specific thing you have, then you can talk to the manager. What is your thing and how it is helpful if you get the tool from the day one, and obviously others will not be benefited, right? Because when you doesn't know how to use the tool, what is the point in using the tool? And if you know how to use the tool, then you can obviously contact the manager to get the information, uh, what is a
Okay,
tool.
sir.
So tool information, if you want, I can give you what tool we are using, right? But still, if you want any other thing, if you want to use a tool, talk to the manager. He will surely help you with this. Or if you want to use e-learning, right, directly, if you are going with e-learning, so there is even a fast course basis, right? Means 20 days program also we have. 20 days we have sessions, only 23 sessions we have, not 23, 20 sessions, 21 sessions we have. Physical design, complete physical design lab, only lab is done in 21 sessions, right? Even that course also we have. So if you want to learn tool in fast manner, even you can approach for that also. See, there is again two things, right? Basics and advanced. Basics is optional. If you feel that you know all these things, then you can skip this part. You can directly enroll for what? Advanced. If you enroll for advanced, obviously directly will give the tool. It's not compulsory you should join the basics. So you can skip the basics.
Okay.
Even will not collect this course fees also for basic course. Directly you can join for advanced. I think advance will start from next week, next Sunday. There's directly advance will start one batch. You can directly join for that. Obviously, from that day the tool will start. Tool will give. All if you take e-learning, right? E-learning advanced course if you take, obviously will give the tool from the day one. This is only
Okay.
the candidates who are joining from the basics. So next we'll go to technical part. So technical part is what is physical design, and what is our course content, right? See, course content, I will share this PPT, whatever PPT I shown earlier. Where is this is our course content. So this I will share to the manager, right? I think he will share you also to all the candidates. So what is our course content? So next I will discuss about its course content. So before that I'll discuss about what is physical design. I think many of the experienced candidates will be knowing what is physical design, right? Just I want to give some introduction to the freshers who have enrolled for this course. What is physical design, right? So when I talk about IC design, right, IC design has two phases. IC, when we want IC, when I want IC to be mark to be present in the market, we have two things. One is IC fabrication, one is what IC design. So we have to fabricate the IC. One another thing is what we have to design the IC. So we have IC fabrication, one is IC design. So what is IC fabrication? Where does it happens? So IC fabrication happens in foundry. So foundry is a place where IC is fabricated, right? So foundry is going to fabricate the IC in nanometer scale, correct? So they are going to fabricate the IC in nanometer scale, means the transistor size in the nanometer level, 10 to the power of minus 9. In the scale, the lowest, if you know if you have a scale, this is a scale. If you see this millimeter, right? This millimeter is what, 10 to the power of minus 3. Means if you divide 1 lakh times, if the small region, if you divide 1 lakh times, then it will become what? 10 to the power of minus 9. That much small the transistor is, right? So fabricating IC is very difficult. Everyone know what is IC, right? Integrated circuit. This IC has millions of transistors inside. Almost the transistor count will be in 3 to 4 crores. The real SoC, system on chip, the count will be in the range of 3 to 4 crores inside an IC. So IC design. So we are IC fabrication is going to fabricate the IC in the foundry, all right? But what is the design will do? IC design engineers, we design the IC by using EDA tools. So EDA stands for yes, electronic design automation tools. Either we use tools from Synopsys, either we use tools from Cadence to design an IC. So after designing an IC, what we will give to the foundry so that foundry can fabricate IC for us. You tell that you understand that the design of IC is completed. So we are going to design IC by using our EDA tools. EDA tool is a software tool which we are running in the computer, like Synopsys for physical design, right? For physical design from Synopsys, we have IGC2 or Fusion. Nowadays we have Fusion compiler, and from Cadence we have Innovus. So when we complete our design by using EDA tools, what we give to fabrication team or foundry to fabricate our IC? What we'll give? GDS file, right? What we'll give? We will give GDS2 file. So what is GDS2 file consists of? So design team will give the fabrication team a GDS2 file. So GDS means graphical data stream information interchange. Right? This file will give to the fabrication team, right? So what this GDS consists of? What is present inside GDS? So it has layout of cells, layout of cells. See, cells means here another name for cell is what? Gate, AND gate, OR gate, inverter. So layout of gates and its connections, right? So this information we have in this GDS2 file. So what is layout? I think everyone know what is layout, right? So when I want to draw the CMOS inverter, so CMOS inverter has what? Top we have what? PMOS. At the bottom we have NMOS, and one side we have VDD, other side source is connected to ground. So this is PMOS and NMOS, both are shorted, and this is V in and this is V out. This is your schematic of the CMOS inverter, right? So why it is called a CMOS? What is CMOS full form? Complementary metal oxide semiconductor. See, these basic questions also they will ask in interview, right? Why it is called as complementary? Yes, when pull up is on, pull down is off, pull down is on, pull up is off. Right? Both are working in complementary fashion. When this is on, that is off, that is on, this is off. Why it is called as metal oxide semiconductor? Here, right? Earlier, this polysilicon was made up of metal. So here, this is metal. What is this? This is oxide, that is SiO2, and this is what? P substrate is semiconductor. For that reason, it is called as what? Metal oxide semiconductor. Earlier, gate was made up of metal. Later, they changed to polysilicon. Right? For that reason, it's called as metal oxide semiconductor field effect transistor. Why it's called as field effect transistor? Because here in the gate, if I apply positive voltage, the electric field is responsible. The electric field, whatever setup, right, that is going to pull the electron. That electron is going to form what? Channel. So electric field is responsible for conduction. So for that reason, it's called as what? Field effect transistor. So in interview, from the CMOS point of view, they may ask these basic questions. What is called as FET, right? So all those things they may ask. This is about your layout. So when you talk about layout, right? When you talk about the fabrication steps, right? You have P substrate, a basic fabrication step. So then you have what? N well. So in the P substrate, I can form what? I can form source and drain of NMOS, correct? This NMOS. It's highly doped N plus region. So this is NMOS. So this is PMOS. So in the N well, I am going to form highly doped P plus region. Right? This is going to form PMOS. This is NMOS. This is PMOS. So this is N well, right? So on top of this, you have what? Silicon dioxide. On top of this, you have polysilicon. Here also, right? On top of this, you have silicon dioxide. On top of this, you have what? Polysilicon. So if you see from the top, what is visible? That is called as layout. What is visible? Gate is visible. Source is visible. Drain is visible. This silicon dioxide and all is not visible. So if you see from the top view of the IC is called as what? Layout. That if you draw, that is called as layout. Right? If you draw the layout of your CMOS inverter, how it will be? See, this is your P substrate, right? See, for simplicity, we draw our PMOS here, but actually PMOS will be on other side, right? It's like this. This is your P substrate. Here we are going to form the N-well. This side. This side we form the N-well like this, right? Here we form the N-well. This region is what? N-well. Here it is what? P substrate. But while drawing the 2D diagram, for visibility purpose, we draw this N-well sideways. But actually this N-well is on other side, right? So this N-well, after P substrate, next I have to draw what? I have to draw N-well, this N-well. Next we have rails. Rails means it is VDD and VSS rails. It's for connecting purpose. This is a metal layer. What is this blue color? It's a metal layer. This is VDD. This is VSS. VDD, VSS. Next is I have diffusion. This is diffusion layer, right? This is N plus diffusion. This is also what? N plus diffusion. So I have diffusion. So in between diffusion, I have what? I have polysilicon. So this is N plus region. This is N plus region. This I'll call it as source. This I'll make it as drain. Right? We can interchange, no issues. So this is source. What is this? Is drain. Right? Here this is source. This is drain. For PMOS, this is drain. This is what? Source. For PMOS, higher potential is always source. For NMOS, lower potential is always source. Because in the NMOS, current flows from what? Always drain to source. In PMOS, current flows from source to drain. So if you don't know all these things, right, then you have to attend what? You have to attend CMOS basics. Right? The CMOS basics, whatever we have done, we will do from the scratch. We will do CMOS basics from the level of semiconductor. What is N-type semiconductor? What is P-type semiconductor? What is BJT? So from that level, we'll do the CMOS basics. So attend the CMOS basics. So now, as I have done my NMOS, similarly I have to do my PMOS. So this PMOS diffusion, and in between I have this polysilicon. And this is your source and drain of PMOS. This is source and this is drain. Right? Then here what is happening? Your gate and gate is what? Gate and gate is shorted, right? Gate of PMOS is connecting to what? Gate of NMOS. So connect here, right? Connect gate and gate. Both gate and gate is connected. And connecting gate, see polysilicon gate and gate is what is this? This is a polysilicon, correct? What is this? This is a polysilicon. So if I have previous cell and this previous cell wants to connect to this cell, it can't connect to polysilicon, it will connect to what? Metal. So I have to create a metal contact for this, right? So metal connection I'll make for this. So here there is a contact cut. Contact cut means whenever you're connecting metal to any semiconductor, you have to make one contact cut. So here you have one contact cut. It's just a making connection from metal to polysilicon. That's it. So there is a contact cut there, and you are making a metal contact here. So this is your V in. This is V in. This is done, right? Your gate and gate is shorted and connected to VIN. So this source of your PMOS is connecting to what? VDD. That connection you have to make. So source of your PMOS is connecting to VDD, right? Connect by using metal layer. This is also metal, this is also metal, right? Both are fine. So I'm making the connection. But here I have to make one contact cut because this metal is connecting to what? Diffusion, right? I have to make one contact cut here. Again here source of NMOS is connecting to what? VSS, this region, right? I have to make that region now. So my source of NMOS is connecting to VSS. So this is one contact cut I have to make. And what is last one? My this drain and this drain is connecting, right? Drain and drain is shorted. This drain and this drain is shorted. So that shorting I have to do, right? This drain and this drain is shorted by using metal layer. I'm making the short. So this is a layout of what? So here I have to make one contact cut. Here I have to make one contact cut. This is a layout of CMOS inverter. Right? So what are the layers you have here? Polysilicon. What is this? This is metal. This is diffusion. And N-well, this green color is N-well. And this pink color is P substrate. Apart from that, you have one more layer called as implant layer, right? Which is going to cover your diffusion, right? Here you have one implant layer. Here you have one implant layer. Implant layer should cover your diffusion layer. This you will study why this implant layer is present. Right? So this is called as implant layer. This is called as P implant layer. This is called as what? N. See, this implant layer is used to form the mask for oxide layers that you'll study in your CMOS basics. This is N implant layer. So this is the layout of your only CMOS inverter, right? But in the IC, you will be having layout of what? Crores of cells. So one cell output will be connecting to what? Next cell input. This cell output will connect to next cell input. This cell also I have what? This cell also I have a layout. So this cell output is connecting to next cell input. So previous cell output is connecting to what? Next cell input. So like this connection of layout of cells is called as what? GDS file. So how many cells I have shown here? 3 cells. But in the IC we will be having crores of cells. So layout of cells and its connection is called as what? GDS file. So this GDS file we give to Foundry, and Foundry will fabricate IC for us, right? They will fabricate IC for us as per the content of what? This GDS. So however my GDS is there, like that they will fabricate IC for us. Right? So next is, then what is the role of physical design engineers here? Right? What he will do? So to understand that, right? So little bit we have to go with the ASIC design flow. So everyone knows ASIC design flow, correct? So little bit we have to understand the ASIC design flow. So ASIC design flow will always start with what? So at last we understood that the design team will give what? GDS file to what? Foundry, and Foundry will fabricate IC for us, right? Again, directly we will not give GDS file. We will do stage by stage. First we will give base layers. Base layers means what? Only will send base layers. What are base layers here? Polysilicon, N-well, implant layer, diffusion, and P substrate. Those are called as what? Base layers. So first only we'll send base layers to the foundries. So foundry will first start forming the base layers. So metal layers are not sent. So first 15 days they will only fabricate base layers. Even that 15 days we have time to do changes in the metal layers. Still we can do changes. Later we'll send metal layers to the foundries. So we'll send GDS file in two steps. One is base layers. Next is what? Metal layers. So still we can do the changes in a metal layer. That is very helpful for PD engineers to do any changes even after the base tape out. Means after sending the tape out is called as tape out, means in industrial term it is like sending your GDS file to foundry. That is called as tape out. So when I talk about ASIC design flow, first we talk about specification, right? If any IC has to be, we have to design, right? First we come up with what? Specification, means what is the content of IC, right? What are the blocks in that IC? Blocks, subsystem, what subsystem should be there, right? What are the IO connections to that IC, right? Input output connections to that IC. So what may be the estimated frequency of clock for each block, right? The entire block in an IC may not operate with the same clock. Entire IC will not operate with the same clock. Each block in an IC, right? If you talk about blocks, means this is a block, right? These are different blocks we have in an IC. ALU block, ASIC block, USB block, Bluetooth block, Wi-Fi module block, Wi-Fi controller block, memory controller, right? These are different blocks we have in an IC. So each block work with different clock. So what is a frequency, what is a clock, and what is the frequency of clock? See, all the ICs, all the blocks, or all the requirement of IC cannot be fabricated by using ASIC design flow. Few will be also fabricated from what? Analog and mixed signals. Means there is a other team called as full custom design team, like PLL, phase lock loop, and this RF circuits. So all those things cannot be fabricated by using digital design, because we cannot write the Verilog code to the analog circuits. Analog circuits has to be fabricated from full custom design team. That is analog design team. So they will do that. But we engineers, what are the blocks we can design? So we do it by using what? ASIC design flow. So when it comes to physical design, right, all the blocks are given to us to combine everything. We have to combine it. So that we'll see later. So in specification, they will decide what are the blocks to the subsystems, what are the blocks and what are the subsystems, what are IO connections to the block, what are the frequency of clocks, what is the power, estimated power. See, power we cannot decide, right? Till the physical design happens, we cannot decide the power. But we will be knowing what is the power, estimated power from the previous experience, from the previous blocks. From previous design, we will be knowing what is the estimated power, what is the area of a chip, what will be the area, how much area they are assigning for us. So everything they'll decide in specification stage. So mainly the specification go with the blocks and subsystems and frequency of clocks at the beginning, right? Because if all power area will come only for physical design engineers. For RTL engineers, main thing is main requirement is what? Implementing the functionality. What are the blocks? What are the clocks? All those things are very important for them. So after specification, right, what happens is the front end engineers, they will not start writing the RTL code. RTL code. They'll start writing the RTL code. They'll write RTL code for each block, right? One person will write RTL code for ALU, other person will write RTL code for what? ASIC, other person will write RTL code for USB, other person will write RTL code for control unit or GPU, something, right? So each person or each team will they will start writing the RTL code. So to write RTL code for each block, right? So they use either Verilog or VHDL. Why Verilog or VHDL? Why it is used Verilog or VHDL? Yes, the advantage of Verilog or VHDL is, see, Verilog or VHDL will allow us to describe the circuit by its behavior, not based on its structure. Right? See, describing a circuit based on its structure is very difficult. See, I will tell you, you take whatever components you want, implement the ATM machine, hardware for ATM machine, whether you can do it. Okay, ignore it. Right? If I ask you, right, tell me the internal structure of D flip-flop using gates. How many can I tell you? How many of yours? How many of your people can tell this internal structure of D flip-flop? D flip-flop. Okay, ignore that. 2:1 mux. Internal structure of 2:1 mux by using gates. Okay, leave about that. 2:1 mux behavior. Can you tell me how it is working? We have I naught, I1, select line, and Y. Right? Can you tell me the behavior? What is the behavior of this? If S is equal to 0, Y is going to take what? I naught. If S is equal to 1, Y is going to take what? I1. This is the behavior of here mux. Right? This is the truth table, right? I can tell in another words, right? Truth table it is. Simple truth table. So everyone can remember truth table. Right? If I ask about D flip flop, what is D flip flop? So D flip flop is nothing but, so we assume that we have only reset, right? The reset is asynchronous. We assume the reset is asynchronous. Right? Reset Q bar will ignore for the time being. So if at all this is clock, this is reset, this is Q, right? Irrespective of clock, if I'm getting clock or not, if reset is 1, logic 1, then Q becomes automatically what? 0. If reset is 0, then at the positive edge of clock, whatever is present on D is passing to what? Q. Then I can tell Q is going to take what? D. Q is going to take D whenever you get what? Positive edge of clock. Then reset is 0. This is the behavior of D flip flop. Simple it is. So if I ask, tell me the internal structure of D flip flop, how many can you tell me? So writing the behavior of a circuit is very easy compared to structural form. Correct? So designer's role is you write in the behavioral form. We use our internal algorithm to convert into what form? Gate form. So they have internal algorithms that will convert to gate form, but we design engineers, RTL design engineers, we write in the behavioral form. So how to write in behavioral form? It's very easy, right? If you use if statement, if s if s equals 0, y is going to take what? Y is going to take I naught, else y is going to take I1. It's very simple. Here also it's very simple, right? Here, as clock is involved, I have to use what? Always set. Even I have to, if I want to use if, then always is required, right? Always clock is required. Always pass edge of clock or pass edge of reset, because reset is asynchronous here, right? I should use pass edge of reset. So here first preference is for what? First preference is for reset, right? If reset is equals 1, if reset is 1, what is your Q? Q is always equal to what? 0. Else, what your Q is going to take? Q is going to take what? D. Simple program it is. See, I have not followed exact syntax. Just so describing the behavior by using if statement, case statement is very easy. So for that reason, what they have done, they have developed the description language, hardware description language. Okay, you start describing your hardware by using the programming languages. Later we convert that into get form. Right? For that purpose, right? Verilog or VHDL is used. So what is the benefit of using Verilog or VHDL? So we can describe circuit in behavioral form. So if you have bigger circuits, right, they will first split into different states. Just if you want, you take a example of ATM machine, right? They will divide into different states. So first state is your reset state. Next state is pin entering state. Next state is amount entering state. Next state is amount dispatch state. Right? They are divided into 4 states. So when it is in reset state, right? Reset state means welcome to Canara Bank. Some photos will be shown on the screen, right? That is reset state. If at all card is not inserted, means the input is 0. Card is not inserted means for the IC input is always going as what? 0. If card is inserted, the sensor will give me what? Logic 1 as input. Then automatically I go for next state. If card is not inserted, be always in what state? Reset state. If card is inserted, go to what state? Next state. So this state is called as pin entering state. So enter the pin. So here two conditions. One is pin entered may be correct or may not be correct. Right? If pin entered is correct, then you go to next state. Pin entered is correct means logic 1. If pin entered correct, internally my software checks whether both pins are matching or not. If both pins are matching, it will produce logic 1 as output. If I get logic 1 as output, go to what state? Next state. If pin entered is wrong, again then go back to what state? Reset state. Right? Logic 0 means go back to reset state. Or pin is not entered for long time, then also go back to what? Reset state. Then my software will give me logic 0, then I will go back to what state? Reset state. Then after pin entering state, next we will go back to what? Amount entering state. Amount entering state means in amount entering state you have to enter the proper amount which is less than your balance. You can enter the amount which is more than your balance, right? If you have 50,000 in the account, you can't ask ATM machine to give 60,000. That has to be evaluated. Next, you cannot enter the amount in give me 434 rupees. It's not possible. It should be in multiple of hundreds, right? If amount entered is valid, then it will go to what state? Next state. So two conditions here. One is amount entered is less than your balance. And second thing is amount entered is in multiple of 100. Then it go to next state. If both condition is not satisfied, then it will produce what? Logic 0 and go back to what state? Reset state. So here amount dispatch state. So here you run your motors. The motor will count the amount, and based on some logic, right? How much amount it will dispatch the amount. If amount is dispatched, right? Logic 1 means amount is dispatched. Go back to what? Reset state. If amount is not yet dispatched, then be in what state? Amount dispatch state only. Right? To be in the same state till the amount is dispatched. So entire ATM machine we have divided into each states, and now for each state, right, start writing the Verilog program. So we have that is what we have described the behavior of ATM machine by using states. These are the bigger circuits are. See, I can't explain you how this Ethernet MAC is working, right? Because that requires a lot of understanding of concepts, packets, and all you have to understand. I can explain you how this SRAM is working. It requires a lot of time. Just I have take an example of a general example ATM machine. Right? So bigger designs, whatever we have, first we convert into states. For the states, we write what? RTL program. So finite state machine, and we write RTL program. After writing RTL program, next what we'll do? So next we integrate all the RTL, right? So because RTL program here written for different blocks, we integrate all the RTL. After integrating all the RTL, next is for what? Design verification. See, physical design engineers doesn't require Verilog. It's your interest. If you want to learn Verilog, you will learn it, right? But physical design engineers should be knowing what is netlist format. Netlist is also Verilog, synthesized netlist. So we will teach you what is synthesized netlist. So physical design engineers require synthesis netlist. We will teach you, but there is no separate course for Verilog because knowing complete knowledge of Verilog is not required. See basics like what is module, what is input, what is output. That's available in everywhere. Right? Even in YouTube, it's available. You can watch that. So we don't want Verilog physical design engineers. I'm sure about that. Understanding complete Verilog is not required for physical design engineers. But understanding the netlist is important. What is netlist? What is a netlist format? So netlist format obviously will teach you. So when we go to the concept of, right, when I use this input files, right, when I talk about this course description, when I talk about input files, right, understanding the input files, at that time, obviously I'm going to discuss about what? Netlist. So how is the netlist? What is the syntax of netlist? How the netlist is written? So everything we'll discuss. So understanding netlist is important for PD engineers. That we'll discuss. Even netlist is also very long. That we will discuss. So what is design verification? So design verification is nothing but verifying functionality of design, right? Of design is called as design verification. Means verify whatever RTL code you have written, which is in the BRL form. Please verify whether it is meeting the required functionality or not. So you have written the program for D flip flop. Verify whether it is working like whether this program is working like D flip flop or not. How do we verify? Apply different inputs. That is called test cases, right? Apply different inputs and verify what is the output. So based on that, you decide whether it's working like a desired program or not. So that is they will do in design verification. It's not so simple how I tell. Design verification is easy for simple circuit, but for complex circuits, it's not so simple. You have to learn a lot of concept in that. Code coverage strategies. That is called as UVM, right? How to do code coverage and functional coverage strategies, how to implement that. So go with learn UVM. So you have to learn system Verilog. All the things are required for that. So after this, we have next step called as. So in between there are steps called as CDC and all, right? So these are small steps. That is CDC, linting, right? We have many steps in between. But major steps is synthesis, right? So what is synthesis? So synthesis is nothing but what? See, my design is in what form now? BRL form. Convert this BRL description into gate level netlist. That is called as what? Synthesis. So convert behavioral description into gate level netlist. So this BRL description is nothing but what? Is nothing but your RTL code. Convert BRL description into gate level netlist. This is called as synthesis. So the meaning is I have to convert my RTL to gate level form. That's it. RTL is in the BRL form. Please convert to gate level form. That is what the meaning of convert BRL description into gate level netlist. So synthesis requires logical synthesis requires. See, there are two things again: logical synthesis and physical aware synthesis. So both we will do in our course. But I am discussing about logical synthesis. So logical synthesis requires three files. What is that? One is no doubt you require input as what? One is RTL. RTL is nothing but Verilog program, whatever you have. What is second thing? See, you have to convert your BRL description into gate level description, right? What gates you have to use? Who will give that? Whether you can use MUX, whether you can use D flip flop, whether you can use AND gate. So what gate you have to use? So those information is present in a file called as a Liberty file, or it's also called as library file, right? Library file. So this file has information about the gates, which gates I can use for synthesis. Right? This has timing and power information of standard cells. So this is created by a library characterization team. They will give us timing and power information of standard cells. Timing means delay, right? Cell delay. Power means there are three types of power: leakage, dynamic power. Right? Dynamic power again does switching and short circuit power. Right? All the power information and timing information of standard cells is present in Liberty file. Then what is meaning of the standard cells? Cells which are important for implementing a circuit. Right? It can be a inverter, it can be a buffer, it can be a OR gate, it can be a AND gate, it can be NOR, NAND, MUX, XOR, D flip flop. These are the basic gates which is required, right? So these are the basic gates which is required to implement any circuit. So these type of gates, even there can be few other gates like AOI gate, OAI gate, right? Latches can be used. Latches are also used here. Latches are also present. Latches. So these are the gates which is present in this dot lib. So use these gates and convert your BRL description into what? Gate level description. So next file is required for synthesis. What is that? HDC. What is HDC stands for? Synopsis design constraints file, or sometimes they'll also call it a standard design constraint file. Cadence doesn't want to use the word synopsis. They'll call it a standard design constraints file. What it consists of? HDC timing constraints, right? It has timing constraints on design, right? Timing constraints means, see, doing synthesis is very easy, but if I have timing constraint, then it is difficult. It is difficult. Right? Timing constraint means mainly the clock frequencies. So my design has to work with the same clock frequency. So synthesize in such a way that my design should work with a clock frequency of 1 gigahertz. 1 gigahertz means what is the time period? 1 nanosecond, right? 1 nanosecond is a time period, because time period is inversion of what? Frequency. So my design should work within the time period of 1 nanosecond. So whether it's working or not, to test this, we do setup and hold analysis that we'll discuss later, or in the advanced class we'll discuss that. We'll do setup and hold analysis, right, to test that. So mainly the clock frequencies, set input delay, set output delay. There are many commands in HTC that we'll discuss during advanced class. So HTC now I can tell it has timing constraints on the design. Right? Means you convert this BRL description to gate level netlist by meeting this clock frequency. My design should work within this clock frequency. Convert in such a way. So after synthesis, what is the output? Yes, it is gate level netlist. So what is this gate level netlist? Gate level, see, RTL is also Verilog program. Verilog or VHDL, right? Dot .2 is extension for Verilog and dot .VHD is extension for VHDL. So your gate level netlist is also a .v or .vhdl. Then what is the difference? Okay, I'm running shortage of time. I'll only tell this. Right. So RTL can use any syntax. It can use if, it can use case statements, it can use assign statements. But what gate level netlist has, right? Gate level netlist has gate and its connections. That's it, right? So it should have only information of gate and its connections. So it cannot have the case statements, it cannot use the if statements, it cannot even use the assign statements also. In Verilog, you have assign statements, case statements. It should be only showing gate and its connections. So that type of file is called as what? Gate level netlist. But RTL can use any syntax of Verilog, or if it's a VHDL program, it can use any syntax of VHDL, which can be synthesizable. So we can use only the syntax which can be synthesizable. Right? There are few syntax which cannot be synthesizable. So we can't use that. So RTL can use any syntax which can be synthesizable. But gate level netlist cannot use any syntax. It should be showing only gate and its connections. That is called as gate level netlist. Right? So to understand this, right, we will take this one example of gate level netlist. For example, this is your totally this is your design. This design has 3 ports, 1, 2, 3, and first 2 ports is connecting to AND gate. You assume it's connecting to AND gate, and third port is connecting to one OR gate, and last port is connecting to one inverter. This is output port. This is my block. So input and output of a block is called as what? Ports. This is called as what? Port. This port I'll name it as M N O P. Right? These are the ports. What is the port name? M and O P. Input and output of entire block is called as what? Ports. But this is a cell, right? What is this cell? AND gate. In the library, in this library, the AND gate name is some name, right? AND2. The name will be complex, but I'm taking simple name AND2. OR gate name is what? OR2. Why 2? To represent it's a 2 input OR gate. OR3 means? Yes, simple it is. Right? What is this? Inverter. INV. So here I have intermediate net. So this is not connecting to either input port or up to the output port. So this is called as intermediate signal. So intermediate signal is called as net. So this net is called as N1. This intermediate signal are called as what? Net N2. This is a design what I got after synthesis. Then how will be your gate level netlist? So your Verilog will always start with a keyword called as module. This is a keyword, right? Module is a keyword, and I should give module name. Module name can be anything. I will give it as temp. I can give any name as module name. Next, I should be writing the input and output of my block. What are the input and output of my block? M, N, O, P. Even my cell has input and output pins, right? So input and output of cell is called as what? Pins. Input and output of block is called as what? Ports. So here M, N, O, P are called as what? Ports. Input and output of cell. Right? This cell has A pin, B pin, Y pin. Here it's having A pin, B pin, Y pin. This is A pin, this is Y pin. So here A, B, Y is called as what? Pins. This is called as what? Ports. So next I have to declare what is the inputs here. What are the inputs here? Input ports for my block. So inputs are M, N, O. What are outputs? Output is P. And I have intermediate signals. Intermediate signals are represented as Ys. That is N1, N2. This is common in both. Even RTL this is same. Even in netlist, gate level netlist this is same. Apart from this, in RTL, you can see if statement, case statements or assigned statements. But here you will see only gate and its connections. So what is the first gate I have? AND gate. So AND two input AND gate. So my synthesis tool will give one instance name. Instance name is U1. So this name is different for different cells. Because in the synthesized netlist, I can have n number of AND gates, two input AND gate. The library name remains same. But one AND gate to another AND gate, I should be having some difference in the name, right? For that reason, my tool will give one instance name. This U1 is called as what? Instance name. Then bracket open. A pin. Dot A means for A pin. What is connecting? M port, right? That right in the bracket. M port is connecting. Comma. Dot B. For B, what is connecting? N port. Comma. Dot Y. For Y pin, what is connecting? Net N1. It is done. So next. Next cell. What is the next cell? R2. For A pin, what is connecting? For A pin, what is connecting? Net N1. For B pin, what is connecting? Port O. For Y pin, what is connecting? Net N2. Right? For Y pin, net N2 is connecting. For B pin, port O is connecting. For A pin, net N1 is connecting. Next is inverter, right? At last, I have only one cell inverter. For A pin, what is connecting? N2. For Y pin, what is connecting? Port P. Right? Port P. So this is called as gate and its connection. Only this information should be present in the netlist. So only I have gates and its connections. See, connection is maintained here, right? Because see, here net N1 is connecting to what pin? Output pin of what? AND gate. And same net N1 is connecting to what? Input pin of OR gate. Then the meaning is what? Output of AND gate is having connection to what? Input of OR gate. Even if I don't give the schematic, from this my tool can understand. Output of AND gate is connecting to what? Input of OR gate. Because net N1 is connecting to output pin of AND gate. Here net N1 is connecting to input pin of what? OR gate. So both are same net. One side is connecting to output pin, other side is connecting to what? Input pin. So both are having what? Connections. So connections can be understood. So here also, right? N2 is connecting to output pin of what? OR gate. But N2 is connecting to what? Input pin of inverter. Then this connection is established automatically. So this is what called as gate level netlist. So gate level netlist should be having only gates and its connections. Right? Apart from that, you should not be having any other things. Right? So this information should be present in the netlist. So I have given only 3 cells, but in reality, how many cells you will be seeing? Right? Yes, it will be in millions, 2 crores. This is called as gate level netlist. So after this, next comes a team called as DFT. After DFT, this gate level netlist will go to DFT. After DFT, the design will come to physical design engineers. So what DFT will do, they will add some additional logic inside the design. In the gate level netlist, they will add some additional logic so that chip can be tested after fabrication. See, after fabrication, you think after fabrication my chip is done, my chip is coming in the market. Not in the market, in the foundry the chip is present. Whether you will, so your design is good, your GDS is good, but foundry they are not sure they are fabricated properly because they are fabricating in nanoscale, and every process happens through chemical process. Means acid etching. Acid etching means when this metal layer is etched like this, right? If etching is not proper, so metal layer is bulged like this, and next metal layer which is very close to each other, So automatically there is a short here, right? Our expectation is to have the metal layers like this. But what is happening here? Both are shorted here. Even foundry will not be knowing that it is shorted. So this is the error in foundry, what they're fabricating, because everything is happening in nanoscale. There will be close together metal layers inside IC. They cannot see every IC, every metal layer, whether it's fabricated properly or not. Right? So then when IC is out after fabrication, how do you verify whether it is working proper or not? My GDS is good. Out of 100 IC fabricated, right, there is a chance that 30 IC may fail. So only 70 IC may work properly because of fabrication error. How do we verify that? So to verify, apply the what? Apply the test cases to IC, means test input vectors to IC. Verify the output vectors from IC. Right? Verify the output vectors from IC. So to do this, this is called as what? Post silicon validation. What is this called as? Testing the chip after fabrication is called as what? Post silicon validation. To do this post silicon validation, some cells are required inside an IC to help this. So those cells are added by which team? Those cells are added by which team? That is called as a DFT team. So they will add in the tool. They are not going to add after the thing. They will add immediately after the gate level netlist is formed. In this gate level netlist, they will add some additional logic so that chip can be easily tested after fabrication. Right? So the DFT team will modify the gate level netlist. After modification, this gate, see, we have separate course again for DFT also here. How to modify it. So what DFT will do? So DFT will add some additional logic. So they will do scan chain insertion mainly here, right? Scan chain insertion they will do after synthesis. After scan chain insertion, the gate level netlist will come to physical design, right? So we'll take just 5 minutes break, quick break. Now time is 12:15. Anyhow, I've started 15 minutes late, right? We'll take a 5 minutes break till 12:20. So after that, quickly we'll see what is covered in physical design. Right? Just for 15 to 20 minutes, we'll see what is covered in physical design. Then again, I'm open to the queries. Then I can conclude the session. Right? Just we'll take 5 minutes break. So offline students, if you want to use restroom, the restroom is we have restroom here at the end for separate for men and women. Right? You can use it. And if you want water, it's available here. Right? Water is available. You can use the water. Just 5 minutes break you take, then you can join again. So now time is 12:16. Again, sharply I'll start after 5 minutes. 21. Yes, right. So, so now our design, right? When we talk about the flow, first we started the flow with behavioral form. Next, the same behavioral form design is converted to what form? Gate level form in the synthesis stage. So this gate level I cannot give to foundry because foundry will understand only what form? Layout form, right? Because GDS2 has what form? Layout form. Now role of physical design engineers is to convert this gate level form to the layout form and create the GDS file and send to the foundry. Right? This is what the thing is. See, physical design is not only the um, I cannot tell the physical design is only converting my gate level form to the layout form. So we have many things there, right? So what is the main thing is we have to optimize the design. We have to improve the design in the form of timing, area, and power. We should see that power is reduced. Right? Timing is we don't have any timing violation, and even our area is less. Right? So all these things we have to take into consideration. Then we have to convert our gate level netlist to layout form. See, first when we start with physical design, right? Physical design always starts with partitioning. Design always starts with partitioning. Partition. Right. So what is partitioning? Partitioning means whenever you have full chip, right? So whenever this is a full chip, so they will estimate for the entire that net list how much full chip is required, full chip area is required. So this will also come from the previous experience also. Previous whatever chip is there, the same chip is the next project. In the same chip only we are going to do the next project. Only few modules are upgraded. That's it. Right? That is why the experienced people have more salary compared to the freshers because they know what is the size of chip, everything, right? So when you have full chip, so this full chip is partitioned into subsystems first. They partition this full chip into different subsystems. So this is one subsystem, and again this is one subsystem. Again this subsystem. Again this subsystem, right? This is the entire full chip is divided into four subsystems. Again, this each subsystem is again divided into blocks. Again, they have divided into different blocks. Each subsystem will have at least 30 to 40 blocks like this. So each subsystem, so block need not to be always a same rectangle shape. It can have even what L shape, even it can have U shape. Right here, you can adopt one more block. So you may have any shapes. It's not always in a rectangular shape. So first this full chip is first divided into what? Subsystems. There will be a full chip team separately. They are working only on full chip, dividing this full chip, making the full chip into what? Different subsystems and interacting, managing the connections between subsystems. And again, there is a separate, and each subsystem there will be a lead. Right? Lead will be working on subsystem, and each lead will be handling subsystem lead will be handling different blocks. So the role of subsystem lead is he will plan within this allocated area of subsystem how to incorporate all the blocks, how to fit all the blocks. So fitting blocks, he cannot fit whatever blocks directly. He should also check the connections. Right? Checking connection is very important. Check the connections. Check the connection means, for example, I am placing one block here. If another block which is having more corrections to this, and I have to place obviously nearby, right? I cannot place very far away. So he has to plan the blocks which has to fit into subsystems. That is the role of subsystem engineer. So here the role comes for the block level engineers, right? Here, this block level engineer, this block level engineer A, block level engineer B, right? So when you go to the industry, first you will start working with what level? Block level. You will not directly go to what level? Subsystem level. See, subsystem level is not nothing but just a plan, right? How to put the blocks inside a subsystem. Just plan it and handle the blocks. Whatever issue coming in block, you should handle the issues. The lead should handle the issues inside the blocks. So every twice a week you will be having a meeting with your lead, subsystem lead. So you should tell what are the issues you are getting, discuss the issue with your subsystem level lead, right? So when I talk about subsystem, right, I'll talk only about one subsystem. Right? So we have been the entire chip is divided into different subsystems. So when you talk about only one subsystem, for example, this subsystem, this is one subsystem. Subsystem again, it can be of different shapes, right? It can be even, it need not to be of a rectangle shape, even it can be of any shape. You assume this is one subsystem. So inside this, he has to plan the blocks. So blocks can be again of different shapes, but for simplicity, I'll take square shape. So this area, you are not going to decide. Your block area, who is going to decide? Your subsystem lead is going to decide. So he will partition this entire subsystem into different blocks. So this partition is not on the area wise, it's a module wise. Module wise means complete one module of Verilog should be given to one person. Complete module. I cannot split this module Verilog netlist to exactly half. Complete one module of a Verilog should be given to one person. So it's module wise splitting. So one block can be of bigger size, other blocks can be of a what? Smaller size. So it depends. Like this. So he'll plan. So every engineer who enters into industry, they will start working with what? Block level design. First 4 years or 5 years or up to 6 to 7 years, we will work with what? Block level engineer. And sometimes when you become very senior, then you will, when you become lead, then you will become a subsystem lead. Then you will work with full chip level. Right? But any fresher or any 2 years, 3 years experience guy, you will start with what? Block level physical design. So here each block, this is called as each block. This each block has a cell count of each block level engineer, he will get separate netlist. He will get his netlist. So you should do physical design of your block. So a subsystem lead will take all the physical design blocks, he will integrate, he'll form a subsystem. And full chip level designer will integrate a subsystem, he will send this GDS to what? Foundry. So this is how the partitioning happens. So block level engineer will get his own netlist. In the netlist, you will be having cell count ranging from, it may range from 50,000 to 30 lakhs. Right? May range from 50,000 to 30 lakhs, means 3 million, right? 1 million is called as 10 lakhs. It may range from 50,000 to 3 million. So because doing physical design after 3 million is very difficult. We have huge runtime. So we cannot do physical design easily. So maximum it will be 3 million or 3.5 million. So you will be doing, so in our course, we will be doing block level physical design. So the cell count in industry will range from 50 lakhs to 30 lakhs. So, but we cannot use the design with 30 lakhs because runtime is very huge. Runtime means to run one command, it takes 2 days to run. Means 2 days ideally we don't have any work in industry, because one command will take 2 days to run. That is what the complexity. For example, if I use the command compile ultra or place up clock up, right, that will take 2 days to run. So because of that complexity, if but here if one command is running for 2 days, so that type of design we cannot do it in the training institutes, right? We take two design which is having a count of 53,000 and another design which is having almost count of 1 lakh, right? So we take two designs. So with these designs, one is one project, another one is another project. We take these two designs and we'll do the physical design. So we do block level physical design. So when I talk about block level physical design, so what is partitioning? Partitioning is nothing but your full chip is divided into subsystems, and again subsystem is divided into blocks. So when we do block level physical design, so first thing is creating core area and die area, right? Create core area and die area. That is called as floor planning. So first step is here floor planning. So in floor planning, first is creating core area and die area. So in the block level design, if I have this core area and outside thing is what? Die area. So this is core area and this is die area. So here we will not call it as die area. In the block level, we call it as block area. Creating core area and block area. So how to create this? What are the commands we have? Generally in the industry, this core area and die area will get from whom? Subsystem level lead. He will only give what is your, because we can't decide. We can't make our block whatever size we want. Because that block ultimately has to fit in what? His subsystem. So he will give us. So in what format he will give us? If he is not giving, how to plan it? At the beginning, in the industry, he may not give. When the project will go in three phases: P1, P2, P3. P3 is early phase, where he himself is not sure what is the area. At the time, we have to support him. We have to create a We have to create an area with 70% free space. Right? We have to create core area and area with 70% free space. He will see whether that area can be incorporated in this. So no, your block is taking more area. Then I have to again still reduce the area. I have to plan my design with less area. So we will discuss how to decide the area of a block. If subsystem lead is not giving the area, how you should decide. What are the commands for that? That we'll discuss. Right? First creating this core area and die area. So next is port placement. Right? I've already told what is a port. Inputs and outputs of a block is called as what? Ports. So here inputs and outputs of a block are called as ports. Ports are just a piece of metal layers, right? So place this piece of metal layers in between core area and die area, right? It is called as port placement. So all these are input ports, all these are output ports. See, I cannot place the ports wherever I like. I should follow the guidelines from the subsystem lead. See, because for example, this is a block what I'm working. This is a block, and I am getting all my inputs from this block. All the inputs, whatever I'm getting from this block. Then all my input ports should be where? It should be at the bottom, correct? It should be at the bottom. All the input ports should be at the bottom, because this block is giving me all the input, all the output of this block is coming as input for my block. Then all my input ports should be at the bottom, and output of my block is going to input for next block, this block. Then all the output ports should be at what side? Right side, right? Here all the output ports should be at the right side. So based on his suggestion, we have to place the ports in between what? Core area and die area. So these ports are just a piece of metal layers. So for this ports, whatever we have seen here, right? What are the ports I have here? M, N, O, P. For this ports name, we will assign piece of metal layer and we will place in between core area and die area here. So input ports, if you are selling place on left side, we have to place on left side. If you are selling place at the bottom, we have to place. So wherever is telling, we have to place the ports. So how to do that? We'll see the commands, right, by using EDA tools. So next is macro placement. So what is macro placement? So macros are complex designs, right? So here also in the image we have macros. Macros are complex designs. These are macros. Whatever is other colors you are seeing, those are standard cells. These are complex designs. Those are not standard cells. So macros are complex cells which are already designed. Which are designed and optimized. Sometimes silicon tested also, right? So like your puliogre mix, what you use in home, right? If you want to do the puliogre from the scratch, first you have to cook the rice, then you have to prepare the puliogre mix from the scratch, then you have to mix with the rice. So what is the disadvantage of that? One thing is time. Second thing is you may not achieve the taste. If you are achieving the good taste, then it's good. Wasting time is good. But if you are not sure whether you're going to achieve the same taste of GRB or MTR, then you will waste of time, right? So at the time, what you do directly purchase from what? Shop, puliogre mix directly mix with what? Your rice. So similarly, if you feel some of the designs layout is already available to me, some ALU I have, arithmetic logic unit, there is no changes. This ALU is already, the layout of ALU is already present. In the previous project, we also already have layout of what? ALU, and there is no changes in that. Then I can reuse directly, right? Why I have to write Varilla code for this? Why I have to write? Why I have to synthesize this? Why I have to? So if I don't have this ALU layout, then this ALU would have been replaced with what? Small cells and its connections. So instead of that, already I have ALU layout, and this ALU layout is of efficient. This ALU is working very efficiently. It's already tested. It's having less area, less power consumption, and better performance we have. So then obviously I can use the same layout here, which is already present. So this ALU, if I implement one from the scratch, it will take hardly, it will take 20,000 cells. So the 20,000 cell I have already, 20,000 cell count is already reduced because cells are present inside the ALU. We are not bothered what is present inside the ALU. Right? We are bothered only external connections from the ALU, right? From these external connections, from the pins of ALU, you start making connections. We are not bothered what is present inside ALU because already we have GDS of that. Puliogre mix, what is present inside, you're not bothered. Only you're bothered about what? Taking that mix and mixing with rice. Inside that, it's already proven. Everyone is feeling happy with that. Right? Then you also purchase that directly and directly use it in your design. So some complex designs which layout is readily available and design is and complex cells which are designed and optimized, right? Those are called as macros. So if you have macros like this, then place those macros layout of macros you place inside the core area and die area. So first we do macro placement because macro count will be less, right? The count of macros will be less compared to standard cell count. Standard cell count will be in the range of what? 330 lakhs, but macro count will be in the range of 10 to 100. That's it, not more than 100. It will be in the range of 10 to 100. In one design it can be 10, in some other design it can be 100, but not generally not more than 100. Rare case you can have 250, 300. It's very rare case, right? But generally it will be within 100, right? So first place these complex cells like this. That is called as macro placement. So after macro placement, we have to do power planning, right? What is power planning? Next is power planning. Power planning means, see, what is our main intention after macro placement? Next step, what I do is placement. Placement means what? The standard cells. What are standard cells? I have the layout of standard cells we place here. See, we are not going to draw the layout. Physical design engineers is not going to draw the layout. Layout is drawn from layout team, and they'll give the layout of cells. So just our role is to place the layout of cells inside the core area. That is only next step, placement step. So when the layout is placed, every cell requires what? Every layout requires what connection? This VDD and VSS connections, right? VDD has to connect VDD, VSS has to connect VSS. So every cell, if I have 30 lakh cells, for 30 lakh cells I have to give VDD and VSS connections without IR drop. What is IR drop? For example, this is my VDD port. Assume that this VDD port. This VDD port is having voltage of 1.5 volts. See, in the lower technology, VDD value will be in the range of 1.5, 0.75 like that. Like your textbooks, it will not be like 5 volts or 12 volts. Right? When we use lower technology, the range of voltage will be in the 1.575 to 1.5 volts. So this is 1.5 volt. I have one cell here. Right? You assume one standard cell is present here, and this standard cell VDD rail is at the top, VSS rail is at the bottom. This VDD and VSS. This VDD and VSS. These are layout of standard cell. Now I want to make the connection. I am making connection from here to here. So if I make the connection like this, right, this 1.5 volt will not reach to this cell. This 1.5 volt will reach to, out of this 1.5, only 1.1 volt will reach to the cell. So remaining 0.4 volt will be lost on the metal layer itself. Because when this cell is drawing the current, right, current will flow on this metal layer. And this metal layer is also having what? Resistance. So resistance and current will form what? Voltage. So it depends upon what is the resistance, depends upon how much current is flowing. Based on that, this IR drop, this IR is going to give me what? Voltage drop on the metal layer. And that voltage drop will convert in form of heat. So one out of 1.5 volts, 0.4 volt is dropped on what? Metal layer, and it's converted to form of what? Heat, and remaining only 1.1 volt will reach to what? Cell. So this is called as IR drop. If IR drop happens like this, right, cell delay will increase. If the cell is having less delay because of less VDD is reaching, what happens? Cell delay will increase. Performance is affected. That is going to create a huge problem again. So because of that, this IR drop has to be reduced. So if I am getting 1.5 volts here, here also I should get either at least 1.49 volts. If 0.01 is dropping, no issues. At least I should get what? 1.49 volts. So this, whatever VDD we have at the ports, the same VDD should reach to what? Cell. So planning like this properly is called as what? Power planning. In power planning, we plan with stripes, rings, and rails, right? That we'll discuss in the stage of what? Power planning. How to do power, how to efficiently do the power planning to reduce the IR drop. So these are the major steps in floor planning. Create core area, die area, place what? Ports, place complex cells first, then do the power planning. So next step is placement. After floor planning, next is placement. What is placement? Place all standard cells inside the core area, right? Place all standard cells inside core area. So we have 30 lakh cells, right? Now they are outside. Now place inside the core area, all the 30 lakh cells. So they are called standard cells because almost their height is same, right? They are almost, they have having small height, same height. For that reason, they are called as standard cells. So place all these standard cells inside core area. So what I am placing now, it is layout of standard cells. What is this? It is layout of standard cells. So So we are not going to draw the layout. We are placing the layout of standard cells. So after placing layout of standard cells inside core area, so we have to do many checks that we will discuss in the advanced part. What are the checks then? We have to check the congestion. We have to check the setup and hold violations. So we have to check the max cap and max trans violations. So what are the checks then? How to eliminate those errors? Right? That we will do it in the advanced part. So what are this? Layout of what? Layout of standard cells. So after placement, next step is what? CTS. CTS means clock tree synthesis. So build a clock tree. See, at the beginning, if I don't build a clock tree, right? If you see this image, one clock port will be connecting to what? All the flip-flops, like this. One clock port will be connecting to all the flip-flops. So load on the clock port is very high. As load on the clock port is very high, I may not get the proper clock signal. Right? One port is now connecting to all the flip-flops here, right? If this is a clock port, this is connecting to all the flip-flops in the design. So how many flip-flops you will be having in the design? At least you will be having 10,000 flip-flops. So one clock port is connecting to 10,000 flip-flops. So all those flip-flops pin capacitance and the net capacitance will become the load capacitance here. So when clock is rising and the clock is falling, means what? This capacitance has to be fully charged. If this is of huge load, then it will take more time to what? Charge, and more time to what? Discharge. So where is the square signal here? Where is the pulse width? This pulse width is lost. So because of huge load, because one port is driving all the cells, right? That is not fair. So for that reason, what we will do, we will split the load. What we will do, we will take buffers. If this is a clock port, we will take the buffers, split the load like this. Now this port is driving how many buffers? Only 4 buffers. So I will be having load here. How much is required? This pin capacitance plus this net capacitance. So how much capacity it's going to form? Only that much load I will be having. Only I have less load here, right? So as I am having less load, so my clock will easily rise, easily fall. So I have pulse width. My clock will rise and fall like this. Again, this buffer will connect to different flip-flops. Some 50 flip-flops. Here we will connect to 50 flip-flops. Again, this, if you want, we can use another buffers. We connect to 50 flip-flops, 50 flip-flops. So we will build a clock tree like this using buffers to reduce the load on what? Clock port. So that is done on CTS. Right? So what is CTS? Reduce the load on clock port by inserting inverters and buffers. So next we do what? Routing. Routing means all my cells, standard cells, are placed inside core area, but I have to connect them, right? So here, according to this connection, so this AND gate output is connecting where? OR gate input. So according to the connections present in the netlist, so make the connections. So here connections means connect by using what? Connect by using metal layers. Connect by using metal layers. This is called as routing. So connect ports, macros, standard cells. All these ports, macros, standard cells connect by using what? Metal layers. That is called as what? Routing. So after routing, after connecting ports, macros, standard cells by using the routing, then we do DRC check, DRC and LVS check. DRC means what? Design rule check. See, my foundry has given some rules between one metal to another metal. When I am doing routing between one metal to another metal, there should be minimum spacing, right? This minimum spacing I have to maintain. If the spacing is reducing below this, my foundry cannot fabricate the IC. There are the rules, and there should be minimum width. If the width of metal layer is reducing below this width, my foundry cannot fabricate the IC. So minimum spacing, minimum width. So rules are present. So whether that rule is maintained or not while routing, right? That is called as what? DRC check. So DRC check means a design rule check. Whether rule specified by the foundry is maintained or not. The checking is called as DRC. Next we do LVS. LVS means what? Layout versus schematic. What is layout here? This is layout. What is schematic here? Schematic is our netlist. For us, schematic is what? Netlist. What are the connections present in the netlist? Same connections are present in the layout or not? We have to check. So here what is happening? AND gate output is connecting to what? OR gate input. Whether the same connection is happened here or not, we have to check. Okay, this is AND gate. The AND gate output pin is connecting to what? OR gate input pin. Okay, the connection is happened, no issues. If connection is not happened, it is called as what? Opens. If unnecessary connection is happened, it's called as what? Shorts. So layout versus schematic will check. LVS will check connections mentioned in the netlist is maintained in the layout or not. If same connections are there, no issues. If unnecessary connections are there, then it's called as what? Shorts. If connection is missing, that is called as what? Opens. So that is reported. So after doing this physical design steps for block level, we also should do some sign off checks. Right? Some sign off checks. So sign off checks are some timing check. Then we do physical verification. Then we do IR drop. Like these checks we do. So physical design is done by using a tool called as Fusion Compiler. Or Innovus. And these sign-off checks are done. See, Innovus is a tool from Cadence. Fusion Compiler is a tool from Synopsys. So these sign-off checks again, they are done by using different tools. This timing sign-off is done. Timing means whether we are meeting setup or setup and hold or not. Timing sign-off is done by using a tool called as prime time. Physical verification is done. Prime time is from Synopsys. Tempus is from Cadence. Physical verification we are doing by using IC validator from Synopsys and PVS physical verification system from Cadence. IR drop, Redoc from Synopsys, and physical verification means same, right? DRC, LVS again we do by using different tool. So these tools are more accurate compared to what? See, because Fusion Compiler is doing many aspects. It's not only doing only checks. So, but these tools are specifically designed only for these checks. Even Fusion Compiler can do what? Timing check. But prime time is more accurate compared to what? Fusion Compiler. Even Fusion Compiler can do this DRC LVS check. But this physical verification tool is more accurate compared to what? Fusion Compiler. So we do sign-off checks by using all these three different tools. Redapt, and here we use Voltus. So when my design is passing through all these sign-off checks, so here timing we do STA, physical verification we do DRC, LVS and ERC, electrical rule check. IR drop we do static and dynamic IR drop, and we do electron migration check. If my design is passing all these checks, right, then we will send our blocks to what? To subsystem level. Again subsystem level, he will do all these checks and he will integrate his subsystem to what? Full chip. Again after full chip integration, he will do all these checks. When this check is met, no issues, then he will send this entire full chip to what? Foundry, and foundry will fabricate IC for us. So here in our design, in our project, we cover block level design, right? This is a two project which I've already told you. So here the cell count is 52,000. Here cell count is 1 lakh, right? So we cover all the things, right? Timing, sign up, physical verification, IR drop. IR drop we don't have redact tool. I told you IR drop sign off we do, right? This IR drop sign off we do. We don't have redact tool or voltage tool. So we do only theory part of this, and remaining all these things are covered in hands-on. So only last part that I clearly mentioned here, it's only theory, right? We are going to do only theory of this, only IR drop analysis. So next is, so this is the outline 3D project block level. This is L-shaped design. So this is our course content, right? We discuss about yes, RLC means obviously it is a part of STA, right? Capacitance, resistance. See, I told about cell delay, right? There is two kind again, right? Cell delay and net delay. So obviously, while coming to net delay, we have to concept. We are working on the concept of resistance and capacitance. Inductance effect is not seen inside IC; it is seen outside the IC. When we have bonding wires, right? In PCBs, we can see inductance effect, but inside IC, we will not see inductance effect. L will not see because it's because of bonding wires. Right? We will see only RC effect inside IC. So we cover that obviously. So what is covered in this? So when we start about the project, I told you right, 2 days theory, 2 days, 4 days lab, right? In the lab and theory, this is covered. First we start with input files in the advanced part. So we'll explain about what are the input files for physical design completely. These are the input files. Next, STA, we'll do static timing and it is completely theory. And this concept of STA is used every step. Even after placement, we do STA. Even after CTS, we do STA. Even after routing, we do STA. Even in the sign off stage, we do what? STA. So to do STA, you should be knowing the concept of STA. So we cover all this concept of STA. Setup and hold analysis, different types of clocks, latency, skew, uncertainty affecting setup and hold, timing exceptions, asynchronous paths, D-rates, PVT conditions, modes, corner scenarios. So timing fixing methods. So all these things we cover. So next, we start with synthesis. See, there are two types of synthesis. One is logical synthesis and physical aware synthesis. Right? So logical synthesis is very easy, but industry follows what? Physical aware synthesis. We start with physical aware synthesis. Right? So physical aware synthesis. Next, in physical aware synthesis, we do. So physical aware synthesis is little bit different. In physical aware synthesis, what we do is first we create what core area, die area, then we do port placement, then we do micro placement. After that, we do what? Synthesis. That is called as what? Physical aware synthesis. So during physical aware, for doing physical aware synthesis, obviously floor plan should be done. After floor plan, doing synthesis is called as what? Physical aware synthesis. So doing synthesis before the floor plan is what I have explained here, right? Whatever I have explained here, I am doing synthesis before the floor plan. That is called as what? This is called as logical synthesis. Logical synthesis is only done at the beginning of the project. Once you know this block requires how much area, right? This block requires how much area. Doing logical synthesis of no use. Then we do what? Physical aware synthesis. So both, see, logical synthesis is very easy, but physical aware synthesis is very so you will learn what is the advantage of physical aware synthesis. See, physical aware synthesis has lot of advantage because physical aware synthesis, during synthesis only my tool will place the cells. It will estimate what is the net length. It will calculate cell delay and net delay. If timing is not met, right, my tool will do the reordering, logical restructuring. It will do. I mean, change the cells. Okay, with the mux I cannot meet the timing. Then change the cell. Instead of mux, use AND gate and try. Right? AND gate and OR gate. Use AND gate and OR gate and try whether I can meet the timing. So it will do logical restructuring many times. Why it is doing logical restructuring? To meet the timing. To meet the timing, what is required? I need what is cell delay and what is net delay. To need what is net delay, I need net length. To need net length, I should be knowing where my cells are placed, right? Then only I can calculate the net length. So from this cell to this cell, what is the net length? 2 micrometer. How I can calculate it is 2 micrometer. Only if I know where this cell is placed, where this cell is placed. So to place this cell, this floor planning should be present. So to calculate the net length accurately, this physical aware synthesis is important. When you calculate the net length accurately, you will be knowing what is the actual net delay. With that net delay, you calculate setup analysis. So with setup analysis, I am getting violation. Then my tool will improve my design to meet this violation. But what happens in logical synthesis, as there is no core area die area and my cell location is not known, so my tool net length, this net length is estimated based on some previous results. It's not actual net length. In logical synthesis, net length is estimated based on the previous result, that is called as wire load model. It's an estimation. It's not the actual net length. So based on this net length, I may get setup violation as I may not get setup violation. So my tool will not do any improvement here. But in reality, if this cell inside core area, it will place here, and these two cells, it is placed very far away. In reality, inside core area, they are placed very far away. So what is the net length between them? Net length is very huge, right? I have more net length compared to this, whatever I got in logical synthesis. Because logical synthesis, as it doesn't know where cells are placed, my tool will estimate from previous experiments. It will estimate the net length by using what wire load model. That is not accurate. That is just an estimation, right? But what is the actual net length? I will get only after placing the cells. See, I have marriage today, next month. What I will do, I will only estimate from the previous results how many can come to the marriage. So I will estimate, okay, do the dinner and lunch for 500 members, 1,000 members. From the previous marriage experience, not my marriage, previous relatives' marriage experience, we can estimate, okay, previous my cousin's marriage, there were 1,000 members, right? So, okay, my marriage also we can expect 1,000 members because we have same relatives, right? So this is the based on estimation. That may not be accurate, but this is based on what? Accuracy, right? Because cells are already placed, my tool can estimate what is the net length. This is based on accuracy. So physical aware synthesis will do the improvement, optimization by placing the cells inside the core area and die area. It will estimate actual net length. Based on that, it will do optimization. Based on that, it will do logical restructuring. So that is very efficient compared to logical synthesis. So here we do, so fusion compiler is used for that purpose only, right? For doing this physical aware synthesis. For doing physical aware synthesis, obviously I should be having floor plan, right? Floor plan is already done here. So here you can see, first read the netlist. So here I should have done read the RTL, right? It's not a netlist. Here it is read RTL. Read RTL. Next elaborate. Next plan what? Core area and die area. Next do what? Macro placement. Next insert ICG. See, all these things are in internal part of synthesis. We will discuss during that. ICG means integrated clock gating cell. If any multi-voltage cells like level shifters has to be inserted, we have to insert it. Next place physical aware of physical only synthesis. Next do what? Power planning. Then do what? Physical aware logical optimization. Means this is a final optimization of synthesis. So here totally synthesis is done. So before synthesis only, what is done? Before synthesis only, my floor planning is also done. So that is called as physical aware synthesis. So here floor planning is already done. Next we do what? Placement. So in placement, what we do, we discuss about types of placement, placement optimization techniques, and what do we mean by placement. There are some placement restrictions like blockages, bounds, and magnet placement. Then we do checks after placement. What are the checks we do after placement? Next, what is the next step? So these are some examples about placement, right? This is a congestion. So wherever I'm seeing red color, I'm seeing congestion. Means congestion means there is shortage of tracks for routing. So after placement, if I don't fix this congestion and if I go to routing stage, I may not route these cells. Route means I may not connect the cells. I feel shortage of space for connecting metal layers. That is called as congestion. So here I can see congestion more. Wherever I'm seeing red color, right? I'm seeing more congestion. I have to fix it. This is a congestion hotspot. So next is clock tree synthesis. So all these things we discuss in clock tree synthesis. Next we do routing. So these things we discuss in routing. Right? So after this routing, so this is a clock tree building, right? This is a clock tree. So this pink, water blue colors you are seeing, those are what flip-flops. In this region, I don't have only one flip-flop. I have 50 to 60 flip-flops, but we have merged to form what? We have merged to show only one flip-flop. But in that location, I have 50 to 30 flip-flops. In between, all these are buffers. I have this many buffers. Why to insert this many buffers, right? We'll discuss. To meet the max transition and max capacitance. So we will insert buffers. So this is a clock tree structure. So one clock port initially it is driving one, two, only two buffers. This buffer is driving this buffer is driving this buffer, and this buffer is driving this cell and this buffer. Like that, the tree is built. This is an example for clock tree. So this is a violation, right? There is a short here, right? Short means what? Here one metal layer is running, which is connecting two cells. Here also same metal layer is running. So here both are what? Shorting each other. They should not run like this, right? This is connecting two cells here. Here one cell is there, here one cell is there. This is connecting some other cells here. One cell is there, one cell is there. So this is connecting one cell, this is connecting another cell. Both are meeting at this point, means both are connecting each other. So this short should never happen. So where are these shorts happening, right? It is shown by these red spots. So all these regions I have shorts. I have to fix the shorts after routing. In LVS, I told unnecessary connections are forming what? Shorts. So how to fix these shorts? So after this, we have this sign off checks, timing sign off, physical verification, and IR drop. Next, during the process of covering project, we also do some advanced TCL. We also write some TCL program because automation is very important part of every design, not only the hardware design, even in the software design also automation is very important. So we can write few TCL programs like this to place the ports, right? It is to create this voltage area. If you want to plan this voltage area, how to create this voltage area, right? So we have TCL program written. So next is to create this macro rings, power planning rings, right? How to create this, and to fix congestion, right? By applying keyboard margin to fix congestion. So this is a program we have, and this is a program for flip-flops with and without the clock gating cells. If I want to identify, this is a TCL program. So similarly, useful skew method, right? How to do useful skew, how to fix setup violation by using useful skew method. We have TCL program for that. So this is to fix DRC violation, opens and shorts. A small TCL program. So this is one of is to get the script to get slack through cells. So I have cell here, 5 micrometer to left, 5 micrometer to the right. find the cells, and find slack through each cell. Right? So this is a TCL program. So like this, we have written few TCL programs. It's only few we have used here, and we have written many TCL programs in the course content. Right? That is covered as part of lab. So when you do the lab for 4 days or on the weekend side, even these TCL programs are covered. So I have done from my side, right? So already it's 112. So if you have any queries, right, you can ask me. So tools, see our plan is to use both the tools, Cadence and Synopsys. From Synopsys we use Fusion compiler. So project will be done by using Fusion compiler. And Cadence, see we have limited license for Cadence tools. See both the tools we cannot bring. No institutes will get both the tools. So we have planned to get both the tools. So till now we don't have Cadence. We are having plan to get. So we already signed a MOU and we are already getting the Cadence tool also. When you're coming to advanced part, right? Cadence tool will be available as per my knowledge. So even we will give, see because that's a limited license, right? We cannot give the tool to everyone. Cadence tool. Fusion compiler is given to everyone. So we have enough license, right? So we will give the tool 24/7 Fusion compiler, but Cadence tool also we will show you how to do even in Cadence. So as we have limited license, I think 5 license we have. On turn basis you can use. Who register first, you can use for first 5 days. Next 5 days, few candidates. Right? But even we show you how to use even the Cadence tool. So learning one tool is sufficient. So when you go to industry, right, you will be having a user guide. User guide is how to use this tool. You are in the class in the UG classes, you will be having lab manual, right? Similarly, you will be having a user guide. So by seeing the user guide, you can learn other tool also. But we will try to show you even how to use this tool. Yes, every class, lab session, theory, basics, every class, live recorded session video will be given. And for physical design, coding is required, but not for large extent, only small programs to make your work easy. I told you, right, if you have 1,000 works, 1,000 times if you want to do repeated works, then it is not good doing one by one. Then you have to write a small program to do that. Right? For that reason, so to create the automation, small amount of coding is required. That is TCL coding is required. So obviously there is a coding in physical design, but it is not like front end. It's not full of coding. It's only small amount of coding you have. Yes, for physical design, TCL is enough. For physical design engineer, if you want to become a PD CAD engineer and all, then you should be knowing Python also. See, Python is no Python. By using Python, I cannot do anything with the tool. Tool can understand only TCL. But what is the advantage of Python? You can do file operations, right? You open any file. In the file, if you want to grab some content, instead of using Tickle also can do that. Instead of doing Tickle, Python can do very easily by using Python. So if you know Python, you have better advantage. But it's not compulsory, you should know Python. Python is not mandatory, should be knowing. But if you know, it is good. If you don't know, because there is nothing to do. We Python with EDA tool, there is no relation. But my EDA tool will not understand Python. It will understand only TCL. For that reason, TCL is compulsory and mandatory. But Python has added advantage if you know. The reason is you can do file operations easily. File operation is independent of tool, right? The file which are, if you have 100 files in a folder, in which file there is a congestion report out of 100 files. How do you verify? Open on file C. Open on file C. Not possible. Then write a small tickle Python program. It will only grep which file. It will only identify which file is that. It will only open that file. Only execute at Python proc. Proc is there. Proc name will be there. Find file, and you give the location where you have to find. Your Python program only find the file and it will only open the file. So to do all these things, Python is important. It's optional to you. Right? If you want to expertise, then it is good if you know Python. I know Python because I want to work with different files, thousands of files. Then I cannot do it manually. Then I will use Python sometime to do it. But TCL is mandatory for physical design engineer. Without TCL, there is no PD. You should be knowing TCL. If you don't know Python, no issues. Even you can do the same operation using Unix. You can do same operation using TCL also. But Python is having very good libraries. We can do easily compared to Tickle and Unix. Yes, any other doubts? Say as soon as you join for the course, right, you will get it. As soon as you join for the course, you will get it. See, as soon as you join for the course, they will give you one in-skill password, username and password. If you get that username and password, then I think you in that it's already loaded. When you will get that, you see, when you join to the course, they may not give you on the same day because of more students enrolling on the same day. They may give you on next day. Right. That's it. You can talk to the admin or you can talk to the manager. He's available now in the ground floor. You can talk to them. Then they will make some arrangement for weekend classes for basics also. They'll do it. You just discuss that with manager, and probably he may not take decision today because admin should come. He will come tomorrow because it's today Sunday, right? We have only manager available in the office, so they will inform you tomorrow. So they will do. They have done many times. They will do it.
Hello, good afternoon, sir.
Yes, tell me. See, if you don't have queries, you can go, or you can leave the meeting. If you have queries and if you want to listen to the queries, you can stay back. It's up to you. If you want to listen to the queries of others, and if you have queries, you can stay. If you don't have any queries, you can leave the session and you can also exit the meeting because already 1:20. It's up to you. Yes, please tell me.
Sir, who is the mentor next section?
No, mentor
Who
is
is
different for different thing, right? Basics you have different mentor. PD you have different mentors.
okay? That's why I'm asking, sir.
Now, which
Who
mentor
is
you
the
want?
nothing like that, sir. Asking.
No, right. I am not sure about that, right? Who will be available at that time? They will alert them. It depends upon
Okay,
the
sir.
load, right? How much load they have. But if you have any specific thing, then you can talk to the admin, or if you can tell me whom you want you as a mentor.
No, no, sir. The
Okay, and fine. Sam, I cannot tell, right? Probably Matsudan will be there for basics as a mentor. For advanced physical design, we are not sure because it's after 2 months, right? If it is a next batch, next advanced batch will start in the next week. We can tell who is a mentor. After 2 months, it's availability. Who is available? We have three mentors available here in the institute. Out of three, anyone will be assigned to take the lab.
okay, sir. Thank you. One thing, when the placements are coming, we are not completed the course, no, sir. We are not completed the course, but
No,
we can
you are
attend.
allowed to take the placements only after completing the course from the institute side.
Okay, sir. Okay, thank you.
Okay, thank you everyone.